Good morning, everyone. On behalf of
Morning.
Indian Fertility Society, it is my proud privilege to welcome you all to the 16th Annual Conference Fertivision 2020 and the first virtual Global Congress of the Indian Fertility Society. In these trying times of the global pandemic of SARS-CoV-2, it is really a difficult task to organize a conference and more so in a digital platform, though it may be very convenient for everyone sitting at home and attending the conference. Indian Fertility Society has many firsts to its credit, and this is just another first, the first virtual global congress. I applaud and thank Dr. Umesh Jindal and a wonderful team for organizing such an academic feast. We welcome stalwarts like Dr. Abha Majumdar, former president of IFS, Dr. Neena Malhotra, and the current general secretary of the IFS. I also welcome all our chairpersons, our speakers, and of course, our delegates. Why do we need to have a workshop on research methodology? The answer lies in the very definition of the word research. Research, according to, what is research? According to the American sociologist Earl Robert Babby, research is a systematic inquiry to describe, explain, predict, and maybe make an attempt to control the observed phenomena. It involves both inductive and deductive methods. So the definition says it has to be systematic. When it has to be systematic, it implies there must be a structured way of doing it. This is where research methodology comes in. It is the very backbone of any research. Quite often we find people start collecting data without following any systematic methodology and are then disappointed when it fails due to faulty methodology and all the hard work is wasted. Guidelines and methodology have been developed over many years and serve as a benchmark for measuring the validity of the results obtained. Failure to follow the guidelines will prevent your findings from being accepted and taken seriously. The protocols can vary slightly between scientific disciplines, but all follow the same basic structure. And of course, original research by the torchbearers that produces new knowledge rather than presenting existing knowledge in a new form. Research is the fodder of the curious and inquiring minds who want to solve a problem. It is driven by problem solvers. I'm sure those attending this workshop are the problem solvers of this fraternity. I'm sure once you understand the methodology of research, you would be keen and confident of carrying out meaningful research and have your papers published and go up the career ladder. Dr. Mohan Kamath, the convener of the workshop, our conveners, Dr. Ruma Satwik and Swati Verma, our co-coordinators, Dr. Monica Verma, Dr. Puneet Arora, Dr. Harpreet Sidhu, our MOCs, Dr. Anuradha Kalra and Dr. Divya Agarwal, have put in a great effort in organizing this workshop. And I'm sure you're going to find this extremely enlightening and useful. Those of you who have joined this one are most certainly the torch bearers of the future. We hope you will all work towards finding solutions and answers to problems which we have no answers yet. Once again, a very, very warm welcome to all of you.
Thank you, ma'am.
Thank you.
Thank you.
Thank you, Dr.
Dr. Mohan, you are speaking next.
Yeah, okay. Very good morning to all my seniors and colleagues and friends. So this is the annual conference for Fertivision, and I'd like to thank IFS for giving us this platform, which is, I think, very crucial and important for, I think, all the youngsters who are looking forward to doing some meaningful research. I'd like to thank the organizing committee and Dr. Umesh Madam and the whole team for helping us organize this virtual workshop and of course the conference which follows this today's workshops. There are some 12 of them. So Dr. Basu Madam has already given a good overview about why research is important. I would say I just like to add one line. As clinicians, we are in the best position to help out plan good research. And this is something that I really truly believe in. So because we are the ground workers, we know exactly where the problems are and what are the knowledge gaps. We can identify them well. And then it's all about designing and executing. So there are a lot of people, those things can be outsourced for, but planning and designing is the key here. So I won't waste much time. I thought I'll just kind of give an overview of today's workshop, 3 sessions. The first session is mainly on observational studies, which I feel we all have discussed this, that we need to generate good observational studies. It's not only important to conduct randomized trials, which are very difficult and have a lot of regulatory issues all the time. So students might find it difficult to pull off in their PGs and residency. So probably the observational studies is something which requires a lot more focus. We have the data, but we need to know how to use it. That's the first session. So after that, we have a very important session, and Dr. Umesh had this idea that let the students who are planning to start a study present their proposals, and we have experts who will critique that. And I think that's something that I really look forward to. All of us should, because we can really brainstorm on refining these proposals. And the last one is just about sharing our experience about how we went about doing studies, but also after the studies are done and what are the problems faced during peer review. So that we have a very a prominent speaker who's associate editor for human reproduction, Dr. Shesh Kamal. So she will give her insight. So it's kind of half-day workshop, and I hope all of you gain from it, as I'm also looking forward to gaining a lot. Thank you. Yeah. Yeah. We move on. So the moderators can take over.
Yeah, this is
Yeah.
Dr. Aradhana.
Yeah, is somebody sharing the screen?
The screen is being shared, Aradhana. Can you see the screen?
Yes, it is visible.
Yeah, Aradhana, please start.
Yeah.
I guess she's unable to, maybe the connection is poor. So
Yeah.
we start with our first session. And for this, I'd like to invite our chairpersons, Dr. Pushpa Dahiya, who's the professor
Yeah.
at the Department of...
I think Dr. Ruma, can I introduce myself, because
Yes,
there is
I
something
think-
wrong is there. Yeah. Yeah.
Glitch.
Yeah.
Ma'am, your
Yeah.
photograph was changed, and I'm so sorry for the photograph here.
No.
Yeah.
Let me say, it's some different person is there. This one.
Yes, ma'am.
Yeah.
We've changed your profile.
No.
At first, yeah, I'd introduce you myself, ma'am. Please give me
No issues. I can just very well understand. Let me first of all thank all the organizers who have given me the opportunity to be there with you all, and for an important session on research methodology. What we say is the research is the key thing for the success for the medicine. So the research has to be continued. So let me introduce myself. I'm Dr. Pushpa Dahiya. I'm the senior professor and head of this obstetric and gynecology department of this postgraduate institute of medical sciences. And right now I'm having an additional responsibility of being a medical superintendent of this postgraduate institute of medical sciences, Rohtak. So I think this is a very important workshop for which we all are here, so that we can learn about. There are various methods of research. It may be a prospective, retrospective, peer review, multi-central study, or lot of things are there on which today we can discuss, and we can find out what is the best method and how our students, they have to go with this. For this, we are having 2 speakers here. The first one is Dr. Sunita Sharma, and the another one is Dr. Richard. Let me invite Dr. Sunita Sharma for the first talk, and she is going to tell us about why do a retrospective study is to be done and how one should plan. Dr. Sunita Sharma, she is a consultant in reproductive medicine and surgery of the Institute of the Reproductive Medicine in Kolkata, and she's having a huge experience of over 15 years in reproductive medicine. She's a faculty of FNB course in reproductive life, and she has a research interest in minimal stimulation IVF and biomarkers of endometrial receptivity, NUMA. She had a lot of publications, 12 research papers in international journal of repute, 11 book chapters she has written, lot of experience with the ma'am, Dr. Sunita Sharma, and she is, apart from various awards, this year's winner of prestigious Robert G. Edward Prize Paper Award for the best paper published in RBMO in 2019. Now, I invite Dr. Sunita Sharma for her presentation on or a talk on why do a retrospective study one should go for, and if we are doing, one has to plan. She is going to tell us about the way to plan retrospective study. Dr. Sunita Sharma, ma'am, please, can you start here? Dr. Sunita Sharma, please.
Thank you, Dr.
Can
Pushpa.
she?
for the
Yeah.
introduction. Good morning, everyone.
And good.
Thank you for the organizer for inviting me to give talk on this topic. Uh, we are going to talk about retrospective study design. This is very important, and this is if we do the retrospective study design properly, this is as good as a prospective studies. So we are going to have a quick look regarding the retrospective study design. Retrospective study, can you see the?
Yes, yes.
Yeah, we can see. Just make it a slideshow, Dr. Sunita. Yeah.
Is it okay?
Nay,
You have to make it a slideshow so that it will be visible.
okay.
Yeah, down one.
Is it
I
okay?
think it's okay. Yeah, now it's okay.
In retrospective study design, what we do is we answer a current research question based on the data collected in the past. Here, the outcome has already occurred, and this design is almost always an observation study because we don't do any individual intervention. Usually, it is a case control study, but we can also do the cohort study. Here, the researchers formulate a question idea about the possible association and try to investigate the potential relationship. What we do in prospective studies is we conceive an idea, we recruit the patient, do the intervention, and outcomes are analyzed. But in case of retrospective studies, what happens? The results and outcome already has happened, intervention already has happened. We just include the patient and we analyze the data to have answered for the research question. This study design is useful in rare diseases where it is difficult to perform the active recruitment. It is a very less time consuming and cheaper than prospective studies. When we are doing a study on a larger study population over a longer period of time, it is more suitable to do the retrospective study design than prospective and RCTs. We can also assess the multiple associations. Like if we are comparing the live birth in two groups, we can also assess the pregnancy complication along with the live birth rate. It also serves as an initial screening. Like if we want to do the prospective or RCT, the data of the retrospective will serve as an initial screening, and the data available will allow us to do a randomized study, which is an observation study where we don't need any intervention or follow-up. It's a non-experimental in nature and we need less resources. Suppose in practice we have any feeling that this point should be highlighted, like when we are doing the IVF, when we analyze the IVF patient, we see some endometriosis patient conceive, other do not conceive. So in spite of having all characteristics similar. Why this is happening to some patients? They have a good pregnancy. So we went through our data and we then observed that the women who are younger have a good pregnancy rate than the women who are around the 40 years age group. That means advanced age group with longer duration of endometriosis have a poor result than the younger women. So we can if we publish this idea, this feeling, so that can be possible only when we go through our retrospective study design. When we have a large data set and information, we don't have to wait for years to collect the data. We can do the retrospective study with this data, large data set. In our clinical practice, we can investigate the medical phenomena if we have data related to that question. Like if we want to know the relationship of AMH, level of AMH and live birth rate, we already have AMH data in our data set. From there, we can do the retrospective study and we can answer the question. It provides a quick answer, like in this pandemic of COVID-19. If we want to know the obstetric complication in COVID-19 patient and pregnancy outcome, this design is more suitable than retrospective studies. If there is a small setup where we have a limited resource, we cannot commit manpower and money. In that case, retrospective studies are more suitable. Data can be collected from easily accessible medical record, insurance claims, or other database such as disease registry, national survey data, etc. To plan a retrospective study, first step is to formulate a well-defined research question that will be answered by our result, by our data. Tools should be considered. First is sample size. It should be bigger so that our study will have a less bias and have a more quality. Random sampling is more preferred method for sampling strategy. Go through the literature review so that we can identify and divide what are the variables to be studied. The person who will retrieve the data and will code have proper training and should have monitoring. Develop and use standardized data abstraction form. Create a data abstraction procedure manual which will ensure accuracy, reliability, and consistency for reviewers and coders. Develop proper inclusion-exclusion criteria. Conduct a pilot study and address the confidentiality and ethical consideration. To take a quick look of the steps like conception, literature review, proposal development, data abstraction instrument, develop protocols, data abstraction, sample, ethics, and pilot study. Multi-center data collection is more preferable than single-centered. That will increase our quality of study. Base sources of data from electronic health records and clinical data repositories. Researchers who use the retrospective design should provide a transparent report and justification for selected methods. And we should have a waiver for patient consent from our ethical committee. Detailed and well thought inclusion and exclusion criteria to be set strictly implemented. There are methodological challenges in the retrospective study design. So best practices should be considered. Use relevant data sources, statistical procedure, and careful interpretation of the result. We should have a reproducibility of the results also. Analyze the statistical power of the study so that to ensure that we have an adequate sample size. Always try to include the maximum number of subject, observation, and variables. So after having all this theoretical discussion, now let us see a well-planned retrospective observational study. In this study, we have analyzed the effect of adenomycin on IVF cycle, where we analyzed the 973 patients. This is a study conducted over a period of 5 years in which we have included 1165 women who were suffering from severe endometriosis, adenomyosis, or both, and tubal factor infertility undergoing their first IVF cycle. We have proper exclusion criteria because we don't need that other co-founding factor will affect our pregnancy rate or our study, it will affect our quality of our study. So we, after excluding the patients, we have 973 patients who were divided into 4 groups. Tubal factor infertility was taken as a control group because here there is no other factor, only the mechanical loss is here. Other 3 groups were endometriosis alone, endometriosis with adenomyosis, and adenomyosis alone, because we want to know the effect of adenomyosis alone apart from endometrial, because endometrial itself do the lower pregnancy rate, and so we want that why is the only adenomyosis which is affecting the pregnancy rate in endometriosis adenomyosis patient. So from where we have this idea, we have in our clinical practice, we know the endometriosis, if associated with adenomyosis, have a poor outcome, but endometriosis only patient have a outcome is okay in only endometriosis patient than other factors of infertility. So taking the notice of the IVF outcome, we designed a question that is the endometriosis affect the reproductive outcome in IVF cycle even after treatment of GnRH agonist, because the studies have showed that after after pre-treatment of GnRH agonist, we have a similar result. So adenomyosis does not affect the reproductive outcome in IVF cycle. We went through the thorough literature survey. We conducted a thorough literature survey using multiple databases such as PubMed, Medline, Cochrane Review, CTRI database. Then we drafted an early proposal where we discussed the proposal with others and adapt necessary changes to formalize the proposal and study design. From our in-house patient database, we have retrieved the data into the Excel sheet as well as in the paper. We plan to abstract and quote the data. Here are few things about our study. This study was done for the 5 years and a large patient population was selected. The study design was a comprehensive, because we took 4 groups: endometriosis alone, endometriosis adenomyosis in combination, and adenomyosis alone, and this was compared with the tubal factor. Here we have taken the strict inclusion-exclusion criteria. We excluded the comorbidities and cofactor, which can also which is also detrimental for the pregnancy. No compromise was made to select the patient and the person responsible for patient recruitment, because the patient recruitment was blinded about the study objective and outcome. We have also taken the ethical committee permission. Waiver for the patient consent was applied for. Now, after having a pilot study, like on 50 patients, all the data was analyzed and the observation was recorded. And in this graph, we can clearly see that tubal and only endometriosis patient have a similar comparable live birth, comparable clinical pregnancy and miscarriage. The patient who have endometriosis with adenomyosis and adenomyosis alone. Here you can see that there is a significant decrease in the clinical pregnancy and live birth, and significantly increase in the miscarriage rate in endometriosis, adenomyosis and adenomyosis alone group. So if we summarize our study, the presence of adenomyosis seems to have adverse effect on clinical pregnancy, live birth, significant increase in miscarriage rate in groups associated with adenomyosis. There is also pregnancy complication in the adenomyosis group. So what we need when we start our IVF cycle is to screen for the adenomyosis. and counsel about the reduced success after IVF treatment and associated complication of pregnancy. There are few concerns about the retrospective study design is the records were not designed for the study. The available data may be of poor quality. There is a missing data and it can affect the quality of study. It is difficult to identify an appropriate exposed cohort and appropriate comparison group. Like in case of recurrent pregnancy loss, what will be the comparator group? Whether it will be a fertile comparator group or the patient of infertility. Differential losses to follow up can also bias the retrospective cohort study. Bias can occur if subjects in one of the groups are more or less likely to be selected. Suppose if we are intending to our research question, we will select our patient in that group more and more. So that can affect our quality of study. So a well-conducted retrospective study using the reliable data set, appropriate statistical method can minimize our systemic bias associated with this design. And evidence is also suggesting that if we compare retrospective studies and prospective studies, there is no evidence that bias is more in retrospective studies. This paper is, though this is retrospective paper, this paper is selected for the Robert J. Edwards Prize Paper Award for the best paper in 2019. So by this you can understand that a retrospective study is not always a poor study by design. A well-designated study with valuable observation can have a significant effect. Planning and education is more important than only focusing on the object outcome. Don't let bias and poor judgment overshadow transparency of the study in your scientific acumen. Formal approach and adherence to the guidelines is helpful. Thank you.
Yeah, thank you. Thank you, Dr. Sunita, for your valuable talk and the suggestions. But usually one sees that the retrospective studies, they are of a bit poor quality, and we are just analyzing the things which have been done in the past. So it may be that that the inferior level of evidence is there in these in comparison to the prospective studies. So, and usually it is the disadvantage. What has been said is the data may be of poor quality, and there's a frequently an absence of data on potential confounding factors also. So there are certain good points also for this, because it is a quick study, and the things are that we can from the already the cases which have been done, we can come to certain conclusion before planning the other study. So I think now we can invite the another speaker. Right now I am not able to see the screen of the other.
Good morning. I'm Dr. Sanjeev Maheshwari. I am now, first of all, now it is right time to congratulate our president, our secretary, and organizing chairperson that we are running the show on time and smoothly.
Yeah.
So now I will like to invite our second speaker, Richard Kirbakar. He's a research scientist biostatics with Professor V.B. Moses at Center for Evidence Informative Healthcare. So he's associated with this center since 2018. Prior to that, he was associated with as a research scientist biostatic with Cochrane South Asia. So his topic for today's talk is biostatics you must know for a retrospective studies. So just now we came to know the value of these retrospective studies. So these can be taken as good as prospective. So now how will we consider these as good as by prospective studies? The requirement probably will be better told by our next speaker, Richard. So the screen is yours, Mr. Richard.
Thank you very much for the introduction. Am I audible, ma'am?
Yes,
you are audible.
All right, just give a couple of minutes. I'll just share my screen. I hope everyone can, look at my presentation.
Yes.
All right. Thank you very much for, inviting me to this, wonderful event. And so I'm just going to briefly,
Slides are not seen.
all right.
Slide.
Okay, just a minute.
Yeah,
Is
now
it
we can
okay
see it.
now? All right. Okay. I'll just restart again. Thank you for, inviting me to this conference. And what I'm planning to do today in my talk is giving you a little background about, what kind of a statistics that you must know for a retrospective study. So with respect to this presentation, one second. Yeah, I don't have any conflict of interest with this respect to presentation. And just to give you an outline of what I'm going to cover today is I'm just going to share a couple of examples on various retrospective design, and then concentrate more on the analysis approach, and then look at the interpretation of these statistical values that you find on, these articles that you are going to read. So I'll start with the first example, a retrospective cross-sectional study. So look at this example. This is an article published in 2020, looking at a retrospective cross-sectional study, endometrial hyperplasia in infertile women undergoing IVF, a retrospective cross-sectional study. And I would like you to just, spend some time here on looking at the results section. And I've highlighted a couple of information here. I don't want you to just, read the entire, abstract. Whereas if you just look at these highlighted, data that are available in the results, and just, observe these values or observe this, information that are there, because there is going to be a question after this, completion of this exercise. Okay, just 1 minute for you to just observe this, what they are reporting here. You don't have to remember the outcome. You don't have to remember the values. At least if you can remember what kind of statistics that they are just, presenting here in this paper. All right.
Yeah. Move on.
Yep. Let's look at the second example, which is in retrospective cohort study. And generally, cohort studies are gender and prospective in nature. As we all know, we need to just follow up the individuals and try to, look for the outcome for a long time, and then wait to, see the outcome to perform a cohort study. We can also perform a cohort study in a retrospective fashion, right? So this is another example, risk of miscarriage in women with endometriosis undergoing IVF fresh cycle, a retrospective cohort study. Again, I'm going to just pause for 1 minute for you to just look at this abstract and just observe, what is presented in the result. I just highlighted a couple of numbers and statistics that they've used here. I hope you have just got that. And if you notice carefully here in the retrospective studies, cohort studies, you also have a control group here. Whereas in the initial cross-sectional studies, there is no control group is available. From retrospective cohort study, you find the result control group which is matched. As you can see that the result says it starts with 1,006 women with endometriosis as a study group, and 2012 unaffected women becomes a control group. So you have an, cases as well as control. You could also consider this as a case control study, but we are not focused on one particular, association here. Therefore, it looks at the terms of a cohort study. Okay, let's focus on the values that are present here. I hope you have just got the information which is present here. And moving on to the third aspect of observational studies, which is in case control design. Okay. Typically, case control design will always be in a retrospective fashion. So there is no way that you can do this in an prospective fashion. Okay, just look at this example again. Here we are looking at association between asthma and the fertility treatment, and it's a case control design of 2,880 women. Okay, and I'm just again going to present this abstract to you. Look at this abstract and observe the results, and notice a couple of information which is presented on this abstract. Okay, just notice here again there's two groups here, 744 cases and 2,136 controls. Okay, there's two groups again here. Okay, we'll proceed. We have just got three examples here looking at these observational studies which are in retrospective in nature. Starting from cross-sectional studies, we looked at all the old records or stored laboratory samples and try to do some sort of a data collection with that and try to present the results. In the second example, we are looking at retrospective cohort study. We are looking at data of the same individuals at multiple time points or multiple record information and trying to figure out what's happening. Whereas in the third example of case control design, we are specifically looking at one particular objective, whether the asthma is linked to infertility treatment. Okay, that is the only focus of this case control design. Okay, looking at all these results, what statistical or details did you observe common in all of these studies? If you can just look at all these examples, I will not I'll just give you the answer directly. So if you just look at these commonly reported statistics across all the studies, you might find this odds ratio. You would have come across this OR. So everywhere you will find this odds ratios, and along with that you also find a couple of values which are presented with percentages, and you also would have come across with p-values and 95% confidence interval. Okay, these are the information that you might come across on all of these studies, and also you might have come across adjusted odds ratios. Okay, what we are going to do now is we are just going to understand what is the analysis approach which you can use for this retrospective study. So if you look at this particular table, I'm just starting with first row which talks about the heading, and looking at each row, I'm just presenting what kind of a data that you might find in your retrospective studies. So if you have data which is in continuous in nature, could be an example of a number of egg retrieved. So you will be presenting level 1 as in descriptive statistics, okay, which is mean and standard deviation if the data are normally distributed. And sometimes you may not always find the data to be normally distributed. Therefore, you go for a median and interquartile range of percentiles. And if you look at the level 2 analysis that you can do with the continuous data that you have, probably you might need to look at the relationship between two variables. As the age increases, whether the egg retrieval is changing. You need to know the correlation between this age and, egg retrieval. That could be the level 2 analysis that you can do. And if you have multiple variables, then you go on to a multivariate analysis fashion where you apply a regression framework for performing the statistical analysis. And if you look at this particular study on asthma and fertility treatment, so this is basically a binary data, which is a dichotomous live birth, yes or no. So if you look at the level 1 analysis that you can do with this kind of data, so you can start presenting the percentage, how many people have delivered a live birth. So you can just describe them with the percentage, and people might sometimes use that proportion or different terminologies. In general, what you come across in articles are going to be percentages. And if you might ask a question, is there an association between the asthma and the fertility treatment? Then you might look for an odds ratios. There are a couple of other ratios are available, especially risk ratios and risk difference that may not be suitable for a retrospective study. Just keep that in mind. So when you do a retrospective study, risk ratios and risk difference may not be really suitable for doing an analysis there. And if you look at the level 3 analysis, then you might probably want to adjust for additional values, additional factors. Then you might take an approach of a logistic regression. Okay. And in all of these design, all of these values that you obtain, you always will be able to calculate a 95% confidence interval. And also along with that, you will be able to, do a p-value or calculation from level 2 onwards. Okay, let's look at an example, see how these levels can be, used in performing a data analysis. Look at this example, asthma and infertility, which is in case control design. It's a very clear objective. There is no, question about what we are interested in. It clearly says that we want to know the association between asthma and infertility. And if you look at the abstract, it clearly tells us that how many cases were recruited. So you look at your previous records and you identify that, 744 women with asthma, and they also little, smart in here, because if you have one control, which may not be a true representation, they have just moved on to 1:3 or 1:4, depends upon, the design that you are just deciding. Okay, they have just able to recruit controls 200 and 2,136 controls with no asthma. And the question here is, among the 744 individuals that we have recruited with asthma, how many of them were, underwent a fertility treatment? That's what's the exposure. And no exposure is the number of no fertility treatment, which is an opposite to the fertility treatment, right? So just wanted you to just look at this first, objective, which is a level 1 analysis, which we want to just present this information in a percentage. So this is the data table that I've just made. So I just always remember, when you just make the tables, you should follow a same order. Otherwise, you will end up calculating with various different formulas. Okay, just pay attention the way that the table has been made first. If you just notice here, the table has made cases versus control, and then looking at the first information, which is fertility treatment. This data 744 is already available with me, and 2,136 also available with me. I'm just going to look at all the previous record of these people and look to see how many of them were underwent a fertility treatment. And I have this first level of analysis as percentage or prevalence or proportion, whatever you want to call. In general, it's called as a percentage. Okay, and looking at this data that I just screened all the information, and you see that there are 85 people who are just underwent fertility treatment, whereas in no asthma there are 142 people underwent a fertility treatment. So we were now able to establish a percentage, which is a descriptive statistics, which tells us that there were 12% of people who are with asthma underwent fertility treatment, whereas in no asthma we have recruited 2,000 participants. We are only able to find 7% of people who are underwent fertility treatment. Now, just by looking at this data, we can look at and see that there are more number of asthmatic people who are just underwent fertility treatment. So this gives us a sign that there is a likely to be an association. So we need to just prove that with a statistical analysis. What we try to do, we just see that I have added an additional column here with no fertility treatment, just to establish all the different values on these 2 by 2 table. So that's what we need to do. So I'm just going to subtract the 744 minus 85. You should get a number over here, and you just subtract this 2,136 subtracted by 142. You're going to get a number over here. Okay, you just do that by manually. Okay, and the second level of analysis is an odds ratio, measures of association. Let's look at that. So as I told before, odds ratio is a commonly used statistics that can be used in retrospective studies. Okay, and odds ratio, especially you can perform in case control design. You will not able to do risk ratios in case control design. Why you cannot use? Because if you notice in the table only provides you the cases and control. It will not give you the total number of people who are underwent fertility treatment. Okay, though you can add this and get a total, but it is not the true representation of people who are underwent fertility treatment. Therefore, you cannot calculate a odds ratio, so risk ratio for a case control design. Okay, remember that we are not proving a causation. This is just an association. Okay, and you can also do this incidence only when you have an entire population of people who are underwent fertility treatment. Then only you will be able to calculate the incidence. Therefore, incidence is not possible in a case control design. So this is a general typical way of making this 2 by 2 table. Disease case and control, exposure and no exposure. So you just have to fill up this table in this order. So the formula for calculating the odds ratio is A divided by C. and B divided by D. Okay, why? Because we know how many people are asthmatic. We have this number over here. How many people are non-asthmatic? We have the number over here. So we are just trying to, look at the odds of exposure among cases, odds of exposure among controls. So if you do the math and calculate it, so what you end up is, getting is you might end up with the same sort of a percentage. And if you notice here, if you divide this 0.12 divided by 0.07, you get an odds ratio of 1.81. Okay, that is a value that you're going to get if you just do the computation by yourself. Right. So I've used an online calculator for calculating this odds ratio, which will help you in giving you the confidence interval along with it. As I said before, so not just stopping with odds ratio alone will not be useful. We need to also do a confidence interval, which ranges from 1.3 to 2.4. So this is a calculation which I performed with the PDF that is available online. You can just download that. And how do we interpret this value? So you're just showing me an odds ratio, which everybody can calculate it by yourself. But how do we interpret this? The interpretation goes like this. If your odds ratio is 1, which means that there is no difference, between the two, group, or you just no association between the cases and the exposure. That is what we are trying to say when the odds ratio is 1. When the odds ratio is greater than 1, which means that the exposure increases the odds of disease. Okay, that is the interpretation when it is more than 1. When it's less than 1, the exposure reduces the odds of disease. Okay, this is a generic format of interpretation, whereas we look at the example and see how we can interpret that. Okay, as I said before, odds ratio equal to 0, you can simply say it is a no association. If odds ratio greater than 1, it increases the risk of disease or it is harmful. If it is less than 1, it is protective, lowers the risk of disease. Okay, now this is an value that we have just found in the abstract that I showed for this asthma and fertility treatment. If you look at this value, exactly the same value which is reported, and the odds ratio is the same. And you also notice that you have an p-value which is reported. This p-value is calculated with the chi-square test, where you can use a couple of online tools for calculating this p-value. So what is this p-value? P-value is just only telling you we have just observed an association which is greater than 1. Is it due to the random chance, or it has happened due to the true association which is there? So when p-value is less than 0.05, it tells you that there is a true association exists between this asthma and fertility treatment. Okay, that's a key idea of p-value. So p-value is not really going to tell you that whether it is a positive association or a negative association. Okay, that you need to infer from this odds ratios. So look at this third level of analysis of the same data. Now we have this univariate analysis odds ratio. You can move on to a logistic regression. Why logistic regression? Because now we are looking at only two variables. One is that asthma versus fertility treatment. Whereas this fertility treatment is affected by age or other factors, we need to adjust for these factors. Then you could look at a model where you just see asthma is a outcome and then adjust for all the other factors, so that you will be able to establish a robust odds ratios to say whether there is a true association or not. Okay. So you could just look at the abstract. This is the entire abstract of that particular study. And if you see that they're just presenting the values for this, univariate analysis, and you also find that this association was borderline significant when adjusted for age, BMI, smoking status, blah, blah, blah. And it says that it is 1.36, starting from 1 exactly, and ranges from 1.85. And if you notice here, the p-value, it's exactly going to be on 0.05. Okay. So just by, with the help of data that is available, we'll be able to just, calculate our percentage and odds ratio. And you can also apply a logistic regression to just, obtain the multivariate analysis, adjusted odds ratios. Okay, and you see the conclusion here, asthma is associated with the higher, is present from here. You see here asthma is associated with a higher prevalence of fertility treatment. Why they control this higher prevalence? Because you see the odds ratio is greater than 1. Okay. So looking at this interpretation aspect, let's look at the example here. So now you see the odds ratio. This is an a hypothetical example. If the odds ratio is going to be 0.78, ranges from 0.66 to 0.93, what will you conclude here? Is it protective or it is harmful? What will you do here? Okay, there's another example. If the odds ratio is going to be 3.26, confidence interval ranges from 1.06 to 8.35. What does this means? And there's a third example. If your odds ratio is going to be exactly 1 and your confidence interval is going to be 0.82 to 1.58, what does this mean? Just look at the interpretation. If you have an odds ratio which is less than 1, we all know that it is protective. Probably asthma is associated in reducing the number of fertility treatment. Okay, if it is less than 1. If it is more than 1, asthma is actually increasing the number of fertility treatment. Okay, that is a key interpretation. When it is more than 1, it increases the risk. Okay, when it is exactly 1, there is no association. We do not know whether there is an association between the asthma and fertility treatment. And if you notice carefully here in all of these examples, okay, this is a visual representation of the value that I showed in a plot. You call this as a forest plot or error diagram about whatever. Say, so you see that the first study which we have, which is at 0.78, and it ranges from 0.66 to 0.92. And you notice here, it is entirely on this side, which is on the protective side. Okay. And the second, odds ratio which I shared is 3.26, 1.06 to 8.35. It is completely on this side, which is telling it is going to be harmful, which means that there is an increased risk of fertility treatment if you're just going to be asthmatic. Okay. And the third example, which shows exactly 1, which is on this line. And then you see that there is no association that we were able to demonstrate it. So why, you might ask you, why it is 1? Okay, this is basically a division that we are doing. Odds ratio is just a division. Okay, if I have 20 people out of 744, the same number of people in the control group or in the cases, you might have a division equal to 1. So 10 divided by 10 is 1. 100 divided by 100 is 1. Therefore, 1 indicates that there is no difference exists or no association between the cases with the exposure. Okay. Thanks for your attention. I hope I've just conveyed, briefly about what is available in the paper and how you should interpret it. If you have any questions, I'm happy to answer. If you have...
Thank you so much.
Thank you, Dr. Ditya. Dr. Puneet, before we move on to the question and answer session, I would apologize for the initial glitch. And I would also like to introduce the mentor of our workshop, Dr. Basu. Dr. Basu is professor and head Department of Obs and Gynae at Max Shalimar Bagh. And Dr. Kamath, who's the convener of this workshop. Tanvi, if you're there, could you please share the slides? Dr. Kamath, who's the convener for this workshop, he's professor of reproductive medicine at CMC Vellore. I would also take the opportunity to now mention the chairpersons. Dr. Pushpa Dahiya, you all know she's the professor and head Department of Obs and Gynae, Rohtak. Dr. Sanjeev Maheshwari, he's a lab director at Jindal IVF. Dr. Puneet, she's a director of Center of Infertility and Assisted Reproduction and senior consultant Milan. And Dr. Swati, who's senior consultant at Jindal IVF. We have some questions in the chat box. I would now give the dais to all the chairpersons. Dr. Puneet, you can go ahead with your questions. And meanwhile, we'll read the questions in the chat box also.
Thank you, Dr. Thanks, Dr. Sukita, Mr. Richard, for such a brief and I would say detailed and informative talk on the retrospective, studies. So this clearly highlights that they are equally important part of a research contribution if done properly and with the proper statistical inputs. So there are a couple of questions in the chat box, which I would like to take first. And then I also have few questions, which I'll keep in the end. So my first question is to Dr. Sunita, and I think she has answered in the chat box, but I will just ask again, do we need ethics committee permission if generally written consent already taken and confidentiality is maintained? So Dr. Sunita, would you just highlight a bit more on this question, please?
Yes, we need, for any study, we need an ethics committee permission, whether it is retrospective or prospective. For the retrospective study, you don't need a written consent, because the written consent from the patient you need for the prospective study, not for retrospective study. But for all studies, we need an ethical committee permission.
And just extending this question, is it only to waiver of kind of a consent like what you said in your presentation? Is this for that purpose? Yeah. Okay, my next question is to Mr. Richard. How would you distinguish between case control and cross-sectional studies?
All right. So cross-sectional studies are, as you know, that it's a one single time point evaluation that you're doing. You're not going to just ask any questions or looking at any records from, details from your patient in the past. So let's say, for example, that you want to use the laboratory stored, data that are there. It's, you have just keep on storing like 10 years of data in the lab or a bank or something. So you want to just look at these, how these, new molecular technique is going to be useful in terms of, identifying something. So you can do a cross-sectional study to just, take a couple of samples from the stored laboratory and you perform your, assessment and get your data. Whereas in a case control design, so you are just going back and, looking at the same individual information in the past. So if you just recruit a person who has asthma, you just want to go back and see whether this person has, underwent some fertility treatment. So if you look at this data, the same individual is contributing at 2 time points. At this time point, as well as in the past, what happens? So when you look at the data time points, it's going to be 2 or 3 time points, which ensures that you are just trying to look at the exposure factor and then, use a case control design. Whereas in the cross-sectional study, we don't have multiple time points, values, which is, this is just a single time point value. I hope I have, clarified that aspect of, design. And you're you're also trying to do answering a different question. Okay, in a case control design, we are trying to look at whether there is a risk factor, whereas in a cross-sectional study, we are just only trying to establish the prevalence. Okay.
And I think the next part of this question was, what is a better measure of association? Is it the odds ratio or the risk ratio in retrospective cohort studies, and why?
Okay. So as I just mentioned in my presentation, we do not know how many people actually, underwent the fertility treatment. So we don't know the number of exposure exactly. So what we are trying to do in a retrospective design, we are just going backward from this time point, onwards. We are trying to see what all data is available to us. We really do not know how many people exactly, underwent fertility treatment. Therefore, you see that we only have the cases and the controls to begin with. Okay. So you really cannot say that, these many people are underwent fertility treatment. So therefore only odds ratio is a best method. And if you look at all the, retrospective studies, you will only able to find odds ratios. You're never going to find a risk ratios reported in any of these articles. Unless, you have another method, there are advanced statistical approach, which you can, use for calculating risk ratios, but it is not robust also to calculate risk ratios. There is no one single measure which is better. It depends on the design that we are choosing. To make it simple, retrospective, use only odds ratios, no risk ratios.
Yeah, okay. So one more question for you, Dr. Richard. How do we, Mr. Richard, how do we decide which type of study to undertake on a given study question? Whether to choose a case control study or a cohort study? So how would you decide that?
Okay, this is a very interesting question. So it depends upon, the design basically comes after. So if you just say that I want to know how many people, underwent fertility treatment among people who are asthmatic, if you look at this question, I'm only choosing one group. There's no control arm. I just want to know how many people are, undergoing the fertility treatment. This just can be answered with the cross-sectional study. I don't have a comparison group there, right? So the question is only to establish what is the prevalence of fertility treatment among asthmatic, individuals. That will be answered by a cross-sectional study. Whereas if I just change my question, is there an association between asthma and fertility treatment? So I need to also have a control group here. When I talk about a risk factor or an association, the question basically that do people who have asthmatic is a high risk of fertility treatment? Then you want to just do a case control design where we add an additional group which is no asthmatic, and then trying to establish an odds ratio to prove whether there is an association or not. It depends on the question that we are interested in. Okay. So if you just want to know the prevalence percentage, just the percentage, it's cross-sectional study. If you want to go beyond level 1 analysis or level 2, then you might look for an a case control or a cohort study.
One more question, Mr. Richard, just on that basis, the study you presented on asthma.
Yeah.
Obviously, there were quite a huge number of controls as compared to the cases.
Yeah.
So how do you eliminate that bias, and how do you decide, like, is there any proportion of the control in the cases you keep?
Okay. If you look at epidemiologically, we are trying to reduce the bias. That's the reason that we go for a more control. If you just match 1-to-1, it is very difficult to match the individual for their prognostic, variables, which might be turned out to be the confounders when you perform your data analysis. Therefore, to reduce those bias, there is a rule that you can just start with 1:2. That's a general principle people follow most commonly, 1:2 principle. Whereas if you look at, a very rare condition, it's very difficult to, find cases, then you probably need to go for an 1:1. So it depends on the context and the question. So you probably, apply. If you have a huge amount of data, let's say 1,000 cases, probably you need to go for 1:4. So it depends upon the availability of data, because it's all retrospective information and you need to retrieve the information from these database. So this 1:1 or 1:2 or 1:4, it can go up to 1:4. That's a maximum. And it depends on availability of data as well. Okay, the more the information, the robust the study is going to be. Okay, and priori, you need to do a sample size calculation to determine that numbers.
Okay, thank you. My next question is to Dr. Sunita. How do you account for differences in practice, change of clinician, lab variables in a retrospective study of long duration?
Interesting question. We should follow a common minimum agreed data from the database. If it is not uniform over a long time, lose some data or take only those data. Those are common throughout. Like before 5 years, AMH was not standardized and we were not doing AMH for every patient. But now we have a AMH for every patient. So if we are doing a study for more than 5 years, either we will not take this AMH in the data, we will exclude the AMH, or we will do the study only for the data which are uniform. That means if it is standardized from that point of time, we will take the data. Otherwise, if it is not uniform, we will not take the data if the data is not uniform.
So you mentioned in your presentation about doing a pilot study beforehand. So is that the purpose of doing it, or is there any other reason for doing pilot studies before designing retrospective studies?
If your pilot study gives answer to a research question, then you conduct the study to the whole subject and you will get the answer. If you don't have an answer with the pilot study, there's no need to do this retrospective study for a larger
And when you design a pilot study, how do you choose your population? Is it like just, at the beginning of your cohort, what you're going to do? I mean, how do you choose which part of the study will have my pilot? And how many people?
Of the subject, whatever we want, we have given the we are doing this study for 5 years, around 1,000 patients, more than 1,000 patients. So we do the study on 10% of the outcome. And this pilot study will refine the study design. So we need to do a pilot study before going for the proper study.
Thank you. Thank you so much. Dr. Swati, do you have any questions?
Yeah, I have a question to Dr. Richard. Dr. Richard, as we know that retrospective studies are considered as inferior quality studies. So do we can modify our data collection or data analysis to improve the quality of retrospective studies?
Oh, that's a very interesting question. And now we have a lot of new development in statistical approach to handle this problem. So now what recently people are trying to do is you might have come across, or I'm not sure, there is something called a propensity score adjustment analysis, where typically if you try to answer a experimental design, you might need to do a randomized control trial, right? Only way to just do that is in randomized control trial. Sometimes you might also use cohort studies, which are largely done. Let's say, for example, that you want to know the efficacy of wearing a helmet. We cannot do a randomized control trial. It's unethical to do a randomized control trial to compare, wearing helmet is useful. You might look at the cohort study or observational data for that, try and see whether there is a benefit with that, wearing helmet. Similarly, certain instance where it is unethical to, do a randomized control trial, people trying to use this, retrospective data that are available in the huge database. Like if you have a database of, 10 years or 20 years of data, then people try to use this data for, trying to adjust these confounders, because generally when we talk about observational studies, we always say there is a bias, as you pointed out, there is a bias, it is inferior, all this comes in. So now there are algorithms in which you can, adjust for these confounders or bias, and then give a score for each individuals. And instead of, using multiple variable in a logistic regression, you just use this propensity score, which you obtain from, assign for each individuals, and adjust only that score, so that, the methodology says that it is more robust in terms of, equivalent to a randomized control trial. Okay, there are methodologies available to answer such kind of questions, but it will require a little bit of, learning about the statistical, algorithms are there. Now the AI and machine algorithms are there. So now the technology is going to be, in future, definitely you might have a lot of these, techniques which are, handy to use to find, answers.
Thank you, Dr. Richard. One more question to you. Is there any way that if we start a study as retrospective and then we continue it as a prospective study to get better outcome?
It's not really try to answer the better outcome. Basically, it's about the feasibility of performing the study. Let's say sometimes you might end up doing a bidirectional study. Okay, you might not anticipate to recruit the subject, initially, but you have data which are lying in the past 1 year. Maybe COVID is an example. You do not find plan for do a study, whereas or when you see your in a clinical record, you find people with COVID. Then you might strike an idea that I might do a study on COVID patients. Okay, if you see that the data are already stored and the entire idea that you have is already available in your database, collected already. So you might plan for a bidirectional study and then see that what happens. But you need to just as you need to get your IRB clearance, FDA clearance, and all that. Then only you can just start a study. You need to just tell a priori in advance, we want to do a bidirectional study looking at past 1 year data and further introspectively collect further 1 year data, and then we publish that work. Just be transparent on what you have planned, and you plan this well in advance at the protocol stage. Don't keep on revising your idea, then you will be trouble.
Yeah, thank you.
Okay, great.
Thank you, Dr. Richard. Thanks a lot.
Yeah, so this was indeed a very interactive, amazing session to begin with. I would like to thank all the chairpersons and the speakers, and we would now want to stick to the schedule and move to the session 2. We open session 2, that's critiquing by experts, and I would like to call upon our chairpersons, Dr. Professor Abha Majumdar. Who doesn't know her? She doesn't require an introduction. She's a teacher of teachers, Director Center of IVF and Human Reproduction at Sir Gangaram. And she's a course director for IFS Fellowship, ISAR, FOGSI, Advanced Training Fellowship. Dr. Harpreet Kaur Sidhu, she's a senior consultant reproductive medicine at Milan Fertility, Chandigarh. And Dr. Abhi Koshi, He's a consultant in reproductive medicine and surgery, Sunrise Hospital, Kochi, Kerala. Welcome. I welcome you all. And should I now be inviting our speakers? Yeah. So are we all here? Now I invite Ruchika Sood. She's a fellow DCR at KJ IVF and Laparoscopy Center, Delhi. Her research proposal is comparison of clinical outcome between 3D marked maximal implantation potential point versus standard 2D embryo transfer in women undergoing ART, a randomized controlled trial. Dr. Ruchika Sood, I would like to hand over the dice to you.
Thank you, ma'am. Very good morning to everyone. Just a second, I'll just. So before I start my presentation, I would like to thank the selecting committee for giving me this opportunity and this platform. The topic is for my presentation is comparison of clinical outcome between 3D marked maximal implantation potential point versus standard 2D embryo transfer, a pilot randomized controlled trial. Implantation failure is a challenge for assisted reproductive techniques. All of us work very hard to overcome this challenge. Be it in the changes in our protocol or the technique, we want to deliver good results. Talking about the technique, American Society of Reproductive Medicine has recommended embryo transfer to be done under transabdominal ultrasound. Widely, two-dimensional ultrasound is used for the same. Three-dimensional ultrasound, as we all know, is relatively a new technique, but holds various advantages. One of the advantage for ART specialist is to determine the maximal implantation potential point by obtaining the coronal section in 3D scan. MIP, as the name suggests, is a point where the embryo, if we transfer at that point, should have the maximal implantation potential for getting implanted. This notion is echoed by various authors. Fang et al. In 2009 did a study and concluded that uterine cavity and catheter placement may be better achieved with 3D ultrasound, which would improve the embryo transfer technique. Gregley et al. In 2005 did a study and said that ET done, embryo transfer done at MIP were associated with good implantation and pregnancy rates. Gregley in 2010 further did a study on cohort of more than 5,000 women and concluded that MIP for embryo transfer increases the pregnancy rate and as well as it decreases the ectopic pregnancy rate. However, there was only one randomized controlled trial done by Saravelos et al. In 2016, which compared these two modalities, that is 2D versus 3D, and found no significant differences between the implantation rate, clinical pregnancy rate, miscarriage rate, and the ectopic pregnancy rate, which was contradictory to the above said studies. So the question is, does 3D ultrasound marked maximal implantation potential point gives better clinical pregnancy rate than 2D ultrasound guided embryo transfer? And so is our primary objective to determine if it is giving us better clinical pregnancy rate. And the secondary objective is to compare if there is any differences between the complications like ectopic pregnancy and heterotropic pregnancy between these two techniques. Ethical clearance has already been taken for the study. It will be a single-blinded pilot randomized controlled trial done at KJ IVF and Laparoscopy Center, Delhi from November 20 till June 21. Total size will be taken, sample size will be taken as 70, each divided into 1:1 ratio in 3D and 2D ultrasound guidance group. That is 35 patients will be there in each group. The patients will be randomized on the basis of their serial number entering into the study. That is, the patients who would be entering at the serial number of 1357, that is the odd number, would be under 3D ultrasound group, and the patients who would be entering under even serial number like 2468 etc. would be under 2D ultrasound group. The patients who would with primary and secondary infertility requiring both fresh and frozen IVF embryo transfer will be included in the study, and the patients with diagnosis of fibroid uterus, adenomyosis, Asherman syndrome, endometrial pathology, patients with uterine anomaly, recurrent implantation failure, bad obstetric history, patients coming directly on day 2, day 3 of the menses, and surrogacy will be excluded from the study. So after assessing for the eligibility and obtaining the informed written consent, patients will be randomized as I've explained before and allocated to 3D and the 2D group. Then after that, mock embryo transfer will be done for all the patients in peri-ovulatory phase. For 3D ultrasound group, we will be obtaining the MIP, maximal implantation potential point, and for 2D group, we will be noting the angle, position, and length of the uterus. So this is a study, this is a picture over here in which the MIP was calculated. Two imaginary lines are drawn from each arising from the cornu in this, and then after that the point of intersection in the middle is taken. The distance from above is measured and is MIP. In this figure, the MIP is 1.30 and is 8 number. Then after obtaining and noting the MIP, a stimulation and ovum pickum will be done as per standard protocol, and embryo transfer will be done by 2D ultrasound only in both of the groups. In 3D group, it will be done at the marked MIP, and in 2D group, it will be done at 1 centimeter as per angle and position mark. Further, patients will be followed up on day 15 or day 17 according to the day of the stage of the embryo transfer. And then after, if the patient comes out to be HCG positive, transvaginal sonography will be done for the confirmation of the pregnancy after 1 week. And then after that, everything will be put under the statistical analysis, and it will be assessment for clinical pregnancy rate, implantation rate, ectopic pregnancy rate, and heterotopic pregnancy rate will be done. So to summarize, embryo transfer is the final and the crucial step in success of ART. Embryo transfer done by MIP is supposed to give us the better results. However, there is no consensus on the usage of MIP. So we are proposing this pilot study for Indian population to test whether the use of MIP for embryo transfer is better than 3D ultrasound technique. These are the references used for the study. Thank you.
Thank you, Dr. Ruchika. I would now want I would request the experts to please give their comments.
Yeah, who is going ahead to give comments out of?
Yeah.
Huh?
Ma'am, you can begin, ma'am.
Okay. So it's a very good study though. Ruchika, I have certain things which I think might help you to make your study better, some suggestions. And one is that you have 35 in the 3D group and 35 in the 2D group. Now in this, you've not specified the day of transfer, which means day 2, day 3, day 5 of fresh transfer. You have not specified the day of frozen transfer. So you will have a lot of subgroups in your just a small batch of 35. And because you brought the word pilot study, so I'm not saying what is the number which you need to show a difference. Otherwise, you need a minimum number, and you have to specify what difference will really make a 3D technique a better method for embryo placement compared to 2D. So first is numbers required, which you sort of given away by saying that this is a pilot study, number one. Number two is, since we don't have a minimal number, then it becomes a very, very large sort of difference between the whole population, because there's fresh transfer, there's frozen transfer within these 35 people, then there's day 2, day 3, day 5. So it's going to bring so much bias into your study. An embryo which is transferred at day 2 and an embryo which is transferred on day 5 will have a lot of difference in implantation potential. Leave apart the MIT, and the numbers are so small that you will not be able to pinpoint whether it is the embryo embryo age, or it is truly the implantation point. This is number one. Number two is that you have used the maximal place implantation potential point. That's what you call MIP, no?
Yes, ma'am. Yes, ma'am.
Maximum implantation potential point, as a point which you've detected by 3D. And you've made a calculation and you've said fundus, say you go down according to what your point says. It could be 1 centimeter, it could be 1.5, or it could be 0.5. I mean,
Yes,
these are
ma'am.
the variations you are expecting to get. When
Yes,
you do
ma'am.
a 2D replacement, you are doing a standard 1 centimeter distance replacement. I wonder how that implantation potential point you will reach with a 2D while you're doing an embryo transfer. It's not so easy. It is very well written and said rather than done. When you're placing your embryo, then to say it is 1 centimeter below the fundus or it is 1.2 centimeters below the fundus looks very, very difficult. And then you are using a 2D over there. So the calculations might change. Then when you go for fresh cycle versus frozen, the volume will change of the whole endometrial cavity, because that's a stimulated cycle, and the frozen cycle is maybe a natural cycle or maybe a HRT cycle. So the volume might show some difference. And that 0.1 of difference, 1 centimeter, 0.1, you said no, you showed a picture 1.1 centimeter. That and having 1 centimeter is not going to show much difference. So I feel that the study needs to be, homogenized in terms of either fresh or frozen. Then the day of embryo transfer, that all embryos should be of the same day of transfer, so that that bias goes. It is a laboratory bias mainly. How good your embryos cross over from day 2 to day 3, or from day 3 to day 5 and 6. Then once they go up to day 6, you might decide on a frozen transfer for them. That frozen transfer assessment done in the luteal phase of a previous cycle, by the time the turn comes for a frozen transfer, could be 3 months away. And I don't know how you would be able to say that, yes, this whatever we saw in our luteal, mid-luteal phase can be sort of extrapolated to the cycle when you did a frozen embryo transfer. So these are my main, apprehensions about your study. And then using 2D as a method is another apprehension. If I would have been doing this study, what I would have done, all 75 patients would have gone assessment of the volume. And then after that, when you did a 2D replacement, you would have done exact 1 centimeter below the fundus replacement. And then later on found a correlation between what the assessment of 3D was, and according to that, what was the volume of the endometrial cavity. And if all the placements were done 1 centimeter below the fundus, then which volume attributed to the highest pregnancy rates. But then you need a very homogeneous implantation, maybe only blastocyst, maybe only frozen cycles, or maybe only fresh cycles, or maybe day 3, all of them. That is all I have to say about your study. You can talk to your seniors and see if they want to make some small changes in your study. Anyone else has a comment, please go ahead.
Ma'am,
I can see Kamath sitting here. Kamath, I mean, you're not an expert, but I've seen you shaking your head a lot.
So, ma'am, the other Dr. Harpreet and Abby will be commenting.
Yeah,
Yeah.
I know. Yeah.
ma'am,
Yeah, ma'am, most of the points you have already covered. Similar apprehensions I had, like the mock ET was done under 3D and the actual transfer is happening under 2D, and there is no homogeneity. That is why what I strongly feel, and it will be very difficult. And another thing, again, you have already pointed that we are doing mock ET in the previous cycle, and the cycle, especially when it's a frozen cycle, again, the things are not similar. A lot of differences we are expecting. So that is definitely there will be many subgroups, which you have already said. I think most of the points ma'am has covered. And then another point which was in my mind, like on what basis we have calculated the sample size. Was there any help we have sought from the RCT which is already done, and what was the sample size in that RCT? So do we have any clue from there? How are we calculating? Why we are keeping 35 as a number? So these were my points. And secondary outcome, we can keep a miscarriage also as a secondary outcome here. We have kept ectopic pregnancy plus additionally miscarriage also we can keep. And in the exclusion criteria also, or in the subgroup, PCOS also should be kept as a separate subgroup. This is what I feel. So these are the points.
One more point I wanted to make, that you have put your inclusion criteria on the day of your mid-luteal assessment. After that, a woman sort of thought normal reserve patient may not respond normally, 2 may not fertilize, may not go up to day 2, the embryos may be very poor. So at various places, you will have to exclude your patients. And then you are losing a lot of patients. So inclusion, after your inclusion criteria at various steps, you should make exclusion criteria. Excluding your patient is a very different thing, that these patients will not be taken, but those which will be taken in the study, you've done a mid-luteal assessment, you start stimulation, you drop out because of poor response, you drop out because of very low oocyte recovery, maybe 1 or 2 oocytes are recovered, they don't even stand a chance to enter your study of embryo transfer and seeing 2 groups, difference between 2 groups. So they fall out. If you have a poor fertilization rate, if you have poor embryo formation on day 2, day 3, they will all fall out of your group. So I don't know how many fallouts you'll have. And then you must have a remarkable difference in the 2 groups to say that, yes, it is statistically significant that, one method was better than the other method. So these are more points which I had thought that I should tell you about these also, because quality of embryo should be the basic thing which will determine your implantation, maybe not the site so much. So they should be absolutely equal embryos, day 5, grade A, B, BA, whatever you get. And then in a fresh or frozen cycle, if you compare, then maybe the implantation site or having an ectopic will be more significant rather than the difference in pregnancy rates.
Dr. Abby? Yeah, come in.
I just have a few points. Dr. Aba and Dr. Harpreet have come out with very valid points. But the first thing is that when you are doing a randomized study, the randomization should be good. Here you have taken odd and even numbers, which is a thing which is not accepted anymore.
Yes, correct.
See a patient directly, the first thing comes up to the hospital number. So you already know which patient is going for which group. So bias comes in there itself. So it would be that part in a different way, like a serial envelope or a computer randomization, which can be easily done. The second part is we Indians are quite used to finding loopholes and using it well, and you have used the loophole of a pilot study. Now, this is good if you're doing it just for the part of learning how to do research and you want to keep
Voice isn't very clear.
Okay. Am I better now?
Yes.
Yes.
Yeah. So when we look at this loophole of a pilot study, you can use it to maybe limit numbers, but eventually a pilot study is always done when you're
Make
doing
it closer.
When you're doing it for a new subject. That means you want to do research on something which has never been done and you want to just try out and see whether this is feasible for a bigger study. Now you have already have bigger studies in published and it has been shown in your slides, and you don't want to do a pilot study again in such a subject. So rather than doing something like a pilot study, you could maybe focus on a certain subgroup which will make it homogeneous. For example, as Dr. Majumdar said, that you could probably want to equate everybody. So why not something which we do very routinely is like frozen embryo transfer for people with polycystic ovaries, a very homogeneous group. Everybody is having a frozen embryo transfer, everybody has got polycystic ovaries, and everything else has been sort of balanced out. So you could, and you can put numbers also. Now with 35 patients each pregnancy rate.
Dr. Abby, you're not audible.
Better now?
I think you can take off your earphones and speak directly. That would be even better.
What we have is you have a pregnancy rate which is around, say, 30%, and you have 8 or 9 positive patients in each group, which are actually a very small number. So don't limit yourself to 35. Start with 35, but you can always add on and make it a much bigger study. Eventually, if you're able to publish, nothing like it, and that is what all of us would like to have. So if you can correct these problems, you will be getting a very good paper out of this. Thank you.
Thank you. I would now like to invite Dr. Samiksha Mishra. She's a fellow in clinical embryology. Yeah.
Sorry,
Yes, sir.
ma'am asked me to just comment one comment for the things. See, it's a randomized trial, pilot studies. It's too big a design for a pilot study. So, doing a randomization for pilot study is something that I would avoid. You can do a, more of a non-randomized design. Do a pilot study, then only build in for a randomized trial. And if you're looking for a randomized trial, you have to get the trial registry done prospectively if you want to stand a chance for publication. Otherwise, it will not get published also. So that's the main comment I would say. Yeah, thanks. Yeah. Thank you.
Yeah. Thank you, experts. I would invite Dr. Samiksha Mishra. She's a fellow in clinical embryology at Akanksha IVF. Her research proposal is identification of morphokinetic predictors of blastocyst development using the time-lapse imaging in Indian population. Please, Dr. Samiksha Mishra.
Yes, to share. Dr. Samiksha. Yeah, okay. Yeah.
Dr. Samiksha, you have 8 minutes. Please begin your research presentation.
Can you, Dr. Samiksha, you can hear us? No, she's not. You can't hear her.
An issue with her audio. I think Dr. Aradhana, you could ask the next speaker to
Yeah,
begin
better.
the presentation.
Yeah, we'll go on.
Yeah. Okay. We'd invite Dr. Kavisha Lambate first. She is from Wings IVF, Ahmedabad, Gujarat. And her research proposal is comparison of clinical outcomes of single blastocyst versus double blastocyst transfer. Dr. Kavisha Lambate.
Yes, ma'am. First of all, thank you everyone and a very good morning. I am Dr. Kavisha Lambade from Wings IVF Hospital, Ahmedabad. I am fellow in clinical ART. My study title is Comparison of Clinical Outcomes of Single Blastocyst versus Double Blastocyst Transfer in Assisted Reproductive Technology. In today's scenario, the goal of ART is to improve the pregnancy and the live birth rates, as well as to avoid hazards of multiple pregnancies. That is, the main aim of our infertility treatment is to have a one healthy baby at a time. Initially, it was there to transfer multiple embryos, which lead to increased risk of twins and higher order births. That is, it will lead to the adverse outcomes like preterm labor, low birth weight, pregnancy-induced hypertension, gestational diabetes, and postpartum hemorrhage, leading to increased perinatal and maternal morbidity and mortality. For these, the solution is to have an elective single embryo transfer. According to Society of Assisted Reproductive Technology 2017, they have defined elective single embryo transfer as embryo transfer when more than one high-quality embryos exist, but it was decided to transfer only one embryo. The favorable prognostic factors, according to ASRM and SAD, are young age, less than 35 years, previous live births and previous successful IVF cycle, and high-quality embryos, euploid embryos, and availability of vitrification. This table format depicts the ASRM guidelines on the number of embryos to be transferred according to the favorable prognostic factors, age, and the stage of embryos. So the aim of my study is to compare the clinical outcomes of single embryo transfer versus double.
Problem with the audio? Can you check the audio of your laptop?
Okay, ma'am. Just a second.
Yeah.
Hello? No, your computer audio. Check your computer audio.
Just a second, ma'am. I'll do.
Yeah, you can manage with this.
1 second, ma'am. Computer audio नहीं चल रहा है.
Everybody needs to mute their I could hear Kavisha very well. There was no obstruction in my hearing, so I think
Yeah, she should
someone
carry
else
on.
is.
We could hear as well. Yeah.
Yeah, I don't know why did you stop her presentation. I think one of the mentors could not, one of the organizers could not hear. But Kavisha, you were very well heard.
Okay, ma'am.
So you can continue,
Clearly
please.
audible, ma'am.
Yes, yes, please continue.
Okay. Am I audible, ma'am?
Yeah, you're fairly audible.
Okay. So should I continue from this slide only?
Yes, yes,
Or from
yes,
this slide?
please. Yeah.
Okay. Okay, sir. So the aim of my study is to compare the clinical outcomes of single embryo versus double embryo. And the primary outcome are to assess the implantation rate and the clinical pregnancy rate in the two study groups. And secondary outcomes are to assess the prevalence of multiple gestation and miscarriage in the two study groups. The inclusion criteria will include age less than 35 years. It would be gonadotropin releasing hormone antagonist cycles with day 5 blastocyst embryo transfer, and frozen good quality embryos will be chosen. The blastocyst grading according to the Gardner's grading system, that is 5AA, 5AB, and 5BA. The inclusion criteria will include endometrial thickness on day 12 less than 7 mm, serum progesterone more than 1.5 nanogram per ml on day 2, ovarian cyst with diameter more than 3 centimeter on day of start of stimulation, submucosal fibroids, women with severe comorbidity and congenital uterine abnormalities, contraindications or allergies to use of gonadotropins or GnRH antagonist, and severe male factor infertility, that is azoospermia and oligospermia less than 1 million per ml. Now the materials and methods. The study period of my study will be 6 months, 4 months for clinical work and 2 months for documentation and statistical analysis at Wings IVF Hospital, Ahmedabad. The design of my study will be prospective observational and sample size will be 60 samples. The analysis will include that outcomes will be compared using chi-square test and student t-test, and it would be found to be significant if p-value less than 0.05 using SPSS version 24. Now the methodology. Controlled ovarian stimulation will be done with gonadotropins from day 2 or day 3 of menses, and subsequently they are monitored with transvaginal ultrasound to assess the follicular size and the endometrial thickness, and accordingly the trigger will be done with injection HCG 10,000 for final oocyte maturation when at least 3 follicles of more than equal to 18 mm size are present and rest should be more than 16 mm. Then after 34 to 36 hours, ovum pickup will be done, and accordingly ICSI will be done, and the embryos are vitrified on day 5 at blastocyst stage, and grading of embryos will be done according to the Gardner's grading system. Then after giving rest of 1 month, endometrial preparation will be done by oral estradiol valerate with 2 mg TDS from day 2 to day 3 of menses, and on day 12, the endometrial thickness would be assessed, which should be more than 7 mm. And accordingly, injection progesterone 100 mg daily started, and embryo transfer will be done on day 6. Before this, the patient should be counseled regarding the risk and benefits of single blastocyst transfer and double blastocyst transfer. And then they are observed that those who are undergoing the single blastocyst transfer, they are grouped in one group, and those who are undergoing double blastocyst transfer, they are grouped in group 2. After that, luteal phase support was given will be the same in both the groups, that is progesterone gel 8% 90 mg daily and injection progesterone depot 500 mg weekly. Then after 15 days, they are assessed for beta HCG and transvaginal ultrasound for GSAC. And then if they are positive, they are assessed after 10 days for the cardiac activity, and subsequently the primary and the outcome measures were calculated. The ethical issues will include the patient's choice versus OBS complications, that is the management of OBS complications and the long-term sequelae of premature birth should be factored in when considering the treatment cost. So the summary of my study is elective single embryo transfer should be encouraged to decrease the incidence of multiple pregnancies and the associated complications. Patients should be counseled beforehand the embryo transfer about the risk and benefits of both the single and double embryo transfer. A single embryo transfer is cost effective. So the future success of ART will be the elective single embryo transfer, that is the power of 1. Thank you. Thank you.
Hello.
Hello.
Yeah, who's going to comment first? I think we can start with a reverse order.
I'm happy comment karo. No worries.
Okay. Right, Kavisha.
Yes, ma'am.
A very good topic, but needs a lot of clarification. One is you have not written the word frozen in your topic, which is the most important thing, I think, because frozen comes right at the end of your...
Ma'am, in the inclusion criteria, I have...
No, it's not inclusion. You are only comparing frozen, right?
Yes, ma'am,
so
only
frozen
frozen.
should come in the title of your research project, that you are only doing frozen transfers.
Okay, ma'am.
So one is this, and you are comparing the results of 2 groups of a prospective trial.
Yes, ma'am.
There is no randomization. How are you going to reduce the bias which will come by your own selection? I mean, what is going to be your selection criteria? That these many patients you're going to take for single and these many for second. Just giving ASRM guidelines doesn't tell us anything. You have to give your criteria, whether it is embryo based, whether it is patient's desire, whether it is the clinician's desire, whether it is previous failure. How have you chosen patients for single and double embryo transfer? That has not been given anywhere.
Okay.
Plus, you don't need to give the methodology for controlled ovarian stimulation so much in your material and method. Most important thing in your material and method, which we really need you to highlight, is how did you exclude? You recruited patients at what stage? After they made blastocysts? That cannot be true. So first recruitment is after you've done their basic testing, ovarian reserve testing, and said, okay, they are all normal reserve patients, they go in for stimulation. Then second is on the number of oocytes. Will you have any exclusion criteria? Then number of embryos, and those only which go up to blastocyst. So, you have to give a very graded selection of all your patients. And maybe if your sample size is, you said how much? 70?
Yes, ma'am. 60.
60 is your sample size. So is it 60 patients in whom a transfer has been done, or is it 60 patients who were recruited in the beginning and then, I mean, maybe only 20 got a transfer done? So transfer, how will you have selection of the transfer when your selection criteria is right in the beginning with age? And, so the whole study is like, either you make your selection criteria that only those patients were selected who made blastocyst and they were vitrified, and we selected out of them who go in for a transfer. You can't make a selection on the age and on the, what were your selection criteria? Let me just go into it once again. What were your selection? Patient's age, euploid embryo. Have you done a PGS for your embryos?
No, ma'am. PGS are not included.
So, all that is quite useless to write in your introduction. Whatever you are doing, that should be your...
Okay, ma'am.
And how have you selected a double transfer? Just tell us that.
Actually, ma'am, it depends upon the patient's choice. I've decided that those after the...
Suppose out of these 70 patients, 60 want to have a double embryo transfer. How will you sort of compare the two groups then?
Okay, ma'am, I'll have the larger group of the patients, and then I'll select the 30 in the... Yes,
these are not decisions to be taken in a minute. You have to sit down with your guide. You have to think what should be your inclusion criteria. I mean, the best inclusion criteria would be patients under, maybe you're not doing a PGS, so patients under 35 where embryos went up to blastocyst stage and they were good grade blastocyst, only they were taken for the study. So it is already the endpoint reached. And then you can exclude out that I took out uteruses which were abnormal or which had problems like adenomyomas or fibroids sitting over there. Then day 12 endometrial thickness signifies nothing in a HRT cycle for frozen embryo transfer. It could be day 18. It has to be maximal endometrial thickness on the day progesterone was started for them. That should be your day of conclusion, because you may give it for 12 days, you may give it for 10 days, and you may give it for 25 days also to get the maximal endometrial thickness, because a lot of estrogen receptors which react very well with endogenous estrogens may not respond as well with exogenous estrogens which we use.
Okay, ma'am.
Okay, so I feel that day should be removed. Then your selection should be that already if you want to include 60-70 patients, then 60-70 patients should have vitrified blastocyst available. And then you can't keep patient's choice. I mean, you don't want to randomize, then you'll have to make some criteria that, these patients were, it has to be your choice, not the patient's choice.
Okay, ma'am.
Whether you are taking for double embryo transfer those who had previous failures, but then that will bring bias again into your study. So it should be the first cycle of embryo transfer. And I think a randomized approach would be very good if they've already made blastocyst and you have in one group. And I think you have to generate computer randomization, not the odd even. That is a very old method, not acceptable. It's not even considered quasi-randomized and not accepted for publication. So if you want the study to be published, randomize your patients, choose according to the randomization, do the first cycle. Your starting point should be frozen embryos available, good grade embryos. Then you would have the best results with least biases. And HRT should be very variable. Yes, HRT is with the same estrogen, with the same progesterone, but the days of HRT cannot be just before starting progesterone, maximum endometrial thickness of this and this was included and others were excluded out. If you did not reach 7 mm, you kept them out of it. If the endometrium grew to more than 11, 12, 13, whatever you want to keep your cutoff, you can sort of take those patients out. I think these are relevant points in my opinion, but then I would want my colleagues also to opine on this
Okay.
study.
Dr. Kavisha,
Yes,
Dr.
ma'am.
Harpreet this side. So already ma'am has given very good points. So in addition to that, I would say regarding the outcome. So it should be a cumulative pregnancy outcome rather when we are comparing single versus double blastocyst transfer rather than
Okay,
clinical
ma'am.
pregnancy outcome. So
Okay, ma'am.
because we all know pregnancy outcome is going to be different as for the literature support. So better would be a cumulative pregnancy outcome.
Okay,
And
ma'am.
another thing is for the secondary outcomes, if we have to compare the outcome of multiple pregnancies, the preterm delivery, any obstetrical differences, if it was there, that would definitely add a value to the study. So these are the two
Okay,
important
ma'am.
points I want to add on to what ma'am has already said.
Okay, ma'am. Thank you, ma'am.
Regarding the study, the main concern has been the bias part, which is something which has to be addressed before you go for the study. Now, in a simple word, I would say, like, if you were somebody who were to do a first transfer, you would be more inclined to do a single transfer. If it is treatment failure, you would be inclined to put more pregnancies. Again, regarding age, there are so many biases which are there. So unless you do a randomized study, this study has got so many weaknesses that it will go nowhere. So you probably need to really think about structuring the study well. In fact, I personally feel if you do a retrospective observational study about embryos which were transferred for one embryo and two embryos, that might have a stronger validity than a prospective study where you have an element of bias already put in before the study starts. That is something you need to really address here. And because the prognosis in each patient is going to be different, each clinician works differently. And finally, what really matters is whether you get a singleton or twin, and you want to avoid a twin pregnancy, but at the same time, you want to get a good success rate also. So the study structure is something which is the major question which we have to address before you proceed.
Okay. Thank you, Dr. Kavisha. You can stop sharing your screen.
Okay, ma'am.
We can now move to Dr. Samiksha Mishra. Her research proposal is identification of morphokinetic predictors of blastocyst development using time-lapse imaging in Indian population. Dr. Samiksha, if your audio is still not sorted, you can share your screen and the experts would give their comments after the screen share is done.
Ma'am, am I audible?
Yeah, you're audible. Yeah. Please share your screen. Yeah.
Yes. A warm welcome to all the ma'am. Is the screen visible?
Yeah. Yeah, please go ahead.
A warm welcome to all the members. I am Samiksha Mishra, presenting the topic study proposal, topic identification of morphokinetic predictors of blastocyst development using time-lapse imaging in Indian population. In a survey by WHO, it has been seen that nearly 15% of world population suffer from infertility, and 1 in every 4 couple in developing countries has been found to be affected by infertility. Assisted reproductive technology is treating infertility for more than 3 decades after the birth of first IVF child, Louis Brown, in 1978. IVF techniques can triple a chance of a couple of having a baby. With time, several new techniques have been developed in the field of ART, like ICSI, INSI, pre-implantation, genetic screening, etc. But the success rate of IVF is still considered suboptimal. That is approximately 35% pregnancy rate and 25% live birth. The most common reason for this low success rate is the quality of embryo transfer. The embryo that looks healthy in lab under microscope may have defects that cause them to degenerate after transfer. To increase the chance of conception, more than one embryos are preferred to transfer. It has been well documented that multiple embryo transfers have several adverse effects, like multiple gestation, significant maternal and neonatal risk. So to overcome this problem, selection of good quality embryo is necessary for transfer. The present conventional method of embryo selection involves evaluation and grading of embryo on the basis of morphology observed once in a day. Embryo development is a dynamic event, and the observations made during embryo monitoring are static. This limits the ability to discern difference between embryos at similar stages. This method is also considered unsuitable because the culture dishes containing the embryo have to be removed from the controlled environment of incubator every time during monitoring. So to overcome this problem, time-lapse technology has become a new option to consider. It is an ideal tool to study the dynamic events of embryo development. Time-lapse technology works on the principle that embryos with abnormalities take different length of time to reach certain developmental stages than normal embryos. It provides morphological, dynamic, and quantitative timing data in non-invasive manner. High-resolution pictures of embryos are taken for from fertilization up to blastocyst stage at fixed interval of time to study the detailed morphokinetics of developing embryo without disturbing their optimal culture conditions. It is also considered as a refinement of present assessment methods. Researchers suggest that precise timing of specific events like pronuclear formation, syngamy, early cleavage events, initiation of blastulation, etc., are indicators of embryo's developmental potential. Aberrant behaviors like multinucleation at 4-cell stage, uneven blastomere size at 2-cell stage, and abrupt cell division to 3 or more cells also determines embryo quality and thus implantation phase. Then, according to studies conducted by different researchers like Wong, Messiger, etc., they have shown that development of human embryo to blastocyst stage is correlated with certain developmental factors with time. And it has also been found that these time-lapse annotations varies with difference in demography, culture media, type of incubator, and several other conditions like. So the aim and objective of this study is the identification of morphokinetic predictors of blastocyst development using time-lapse imaging in Indian population. As we know that these annotations vary with different conditions, till now there is no study confirming the international annotations for blastocyst prediction in Indian population. So to confirm these annotations in Indian population and to evaluate our own Indian morphokinetic predictors, we are conducting this study in Indian population. The methodology of this study will be, this is a prospective observational study at Akansha IVF Center. Time duration will be from December 20 to May 21, and the sample size of 35 patients each is calculated by the given formula. After taking the consent from the patients, they will be enrolled for the study. The inclusion criteria will be female of age 25 to 35 years, BMI of female patients will be from 19 to 25, and the normal respondent patients will be included. The exclusion criteria will be female of age more than 35 years, previous fertilization failure, and poor responding patients. The procedure involved in this study will be the conventional protocols that is followed during IVF procedures like ovarian stimulation, oocyte retrieval, ICSI, and then the oocytes after fertilization will be cultured in primovision time-lapse. The embryos will be assessed on the basis of morphology and morphokinetic parameters for 5 to 6 days, and the time-lapse data will be evaluated for annotating morphokinetic predictors. Statistical analysis will be done to calculate the rate of blastulation, implantation, and clinical pregnancy. The expected primary outcome from this study is the identification of morphokinetic predictors of blastocyst development, and the expected secondary outcomes will be the rate of blastulation, implantation, and clinical pregnancy. Thank you. Thank you, ma'am.
Make sure you could stop sharing your screen so that everyone else is visible.
Yeah, should I start again or someone else would choose to start commenting first?
Ma'am, you'd be the big star pick.
All right, so this is Samiksha. Samiksha, I think you had only 4 slides describing your study. The rest was all explaining what time lapse is. I don't think so much of introduction is required when you're doing a study for a procedure, which is quite well known all over. You're showing it in an Indian population. You are trying to work out algorithms for an Indian population. That is understandable. Where is your embryo transfer? You are looking at clinical pregnancy rates, but there is no mention of embryo transfer at all. Then how did you, what statistical analysis did you use to reach a number of 35? I mean, what type of difference would you want to see? Are you looking at historical controls and then trying to determine what is the advantage of using the time-lapse morphokinetics vis-a-vis a morphological assessment of embryos? How did you do your embryo transfer? Whether they were frozen, whether they were fresh, whether they were, on which day were they? So, this is a very, very incomplete sort of a study. Mainly we needed your aims and objects, and we needed your material and methods in terms of, and then when you write inclusion criteria, inclusion is less than 35 and good ovarian reserve. Exclusion is more than 35 and poor ovarian reserve. It doesn't make inclusion exclusion. Exclusion are at various points according to me in a study. Like we propose to start with 200 patients and at the end we may just get 60 patients, whom we desire would reach a stage which you could assess. So your idea is not just assessment of embryos, it is also clinical pregnancy rate, implantation rate, and embryo transfer is totally not mentioned anywhere in this study. I mean, these are the major things which I could draw. I lost my internet for just about 2 or 3 slides, but when I came back again, you were only talking about time lapse. So I wish others can comment on this, because this is all I could gather from what I heard out of your presentation.
Yeah, ma'am, same here. Again, my comments, again, I could not make out like on what basis we are going to do the embryo transfer. Is it on the basis of morphokinetic parameters or it's on the basis of morphological parameters? It's a question mark again in my mind, exactly same way. And is the timeline from oocyte to retrieval to exceed defined again? And I have a list of inclusion criteria which was there or not. Like a lot of factors can affect the blastulation formation, severe male factors, surgical retrieved sperms, and all those factors. Like all these factors in the methodology and in the inclusion, those are not there, which we are looking at in any particular study, the basic parameters. So ma'am has already highlighted. So this is what again, like I want to know, when you are going for embryo transfer, on what basis are you going to do the embryo transfer? And are you going to correlate the final pregnancy outcome with the morphokinetic parameters, or you're going to correlate the morphological parameters with the morphokinetic parameters? What exactly we are looking at in this study?
Ma'am, we will be doing fresh embryo transfer depending upon by comparing the results from both the studies, from the case group and from the control group.
Where is the control group? Where did you describe the control group? Where did you describe the embryo transfer? Where did you write fresh embryo transfer? You've not written one word about embryo transfer, Samiksha. And you've never made a control group in this. You just said 35 patients. How can you have a control group in 35 patients? Are you looking at historical controls? I mean, add something that you're looking at historical controls with similar embryos. What embryo stage are you transferring? How will you compare the clinical pregnancy rate? 35 patients, it's a very small number. You just say it's an observational study for 35 patients where we are doing it. And you must describe the embryo transfer. When is it being done? What stage? What type of embryos you are taking according to your morphokinetics? Sorry to again barge in, but I need the third expert's comment also.
Yeah, it's more or less reflecting what you have said. The material and methods of the actual study came in and came off so fast that I didn't realize what was actually the study about. So that's probably the focus which should have been. And I mean, it's a study with a lot of potential. There's a lot of research coming up and we need good data from India. So I think maybe you can just organize things, make it a bit more elaborate, fine tune on the points which you would like to speak about, write about and study. And I think it would be a very good study. So just put more effort on that and that should be good. Thank you.
Yeah, so I think what you need to do, Samiksha, sit down again, take out all the gibberish from what you've written in your thing, you know, about time lapse. Just one slide about time lapse is good enough to say that it does have advantages. And we need every lab, in fact, requires its own algorithm to see what is the, you know, how do you interpret your data about the time lapse embryos, and then come at a uniformity. Start from there, that once you've made embryos and they've gone through time lapse, are you just doing a cohort study, a pilot cohort study, or you are comparing it with your historical controls, and then reach a number which is necessary, and write more about the material methods. That is all I would want you to do.
And I will certainly do the correction in my study. Thank you, ma'am.
Thank you,
I congratulate the team for finishing it in time. This is so beautifully maintained. Very happy about it, Dr. Ruma Satvik and Dr. Kamath.
Yes,
and especially the organizers doing a great job.
Thank you, ma'am. Thank you for your input.
So I would like to thank our experts and the speakers. And we now move to our third session. And before that, I would like to invite Dr. Divya Agarwal. She is the director of Ayushman Multispeciality Hospital, Varanasi, and she would be your MOC for the next two sessions. Thank you, Dr. Divya.
Yeah, thank you, Dr. Aradhana. Thank you for your nice words. Now it's the start with the session 3. I would like to
just a second. Could you also introduce Dr. Aradhana? In our glitch in the morning, I think just things happen so quickly. The audience still doesn't know Dr. Aradhana. So just one line about her before you move on to the next
Dr.
session.
Aradhana is associated as she's a senior consultant at Max Milan Hospital, New Delhi.
Thank you.
Okay.
Thank you, everybody. I was your MOC for the first two sessions, and now we give it over to Dr. Divya. Thank you.
Yeah, thank you, Dr. Aradhana. Now I'm going to start with the session 3. For this, I would like to introduce our esteemed chairpersons. First of all, I would invite Dr. Neena Mehrotra. She needs no introduction. She is the professor, ART Center, Department of Obs and Gynae, AIMS, New Delhi. And she is the Secretary General of Indian Fertility Society from 2020 to 22. Now also invite the second chairperson, Dr. A.G. Radhika. She is the Consultant Obs and Gynae, University College of Medical Sciences and GTB Hospital, New Delhi. She is the National Coordinator, FOXI Clinical Research Committee. Now I invite our third chairperson, Dr. Ruma Satvik. She needs no introduction. You're already hearing her from morning. She's the Consultant Center of IVF and Human Reproduction, Sir Ganga Ram Hospital, New Delhi. And she's the co-convener, IFS, Special Interest Group of Research Methodology. Now I am going to invite, I welcome you all. I am going to invite the study presenters. First of all, I would invite Dr. Harpreet Kaur. She is the consultant at Milan Fertility Center, Chandigarh, and her proposed title is to study the predictive value for endometrial thickness for assessing neonatal birth weight. Over to you, Dr. Harpreet.
Sorry, there is some confusion. I am Dr. Harpreet Kaur, IFS Fellow with Dr. Sudha Prasad at Matrutva IVF Center. Yes, I'm sharing.
The title is okay?
Yeah, title is okay.
Okay.
Yeah, my study is just.
You can share your screen. Yeah.
So my study is predictive value of endometrial thickness for assessing neonatal birth weight, and my mentor is Dr. Sudha Prasad. So endometrial.
We would like to see the slides, please. I am not able to see the slides.
Sorry. Let me try again.
Request you to share your slides.
Share the screen, Dr.
Yeah, I'm doing. Visible now?
No, it's not visible. Dr. Harpreet?
Okay, I'm trying again.
Make it full screen and then share your screen.
Backend team needs to mute everybody else, please.
Is it visible now?
Yeah.
Yeah, it's visible. You can start.
Yeah, so is it
Yeah, it's okay now.
okay? So my study is to know the predictive value of endometrial thickness for assessing neonatal birth weight, and my mentor is Dr. Sudha Prasad. So coming to a short introduction, endometrial receptivity is one of the major factors that determines the implantation success in IVF cycle. And we usually measure endometrial thickness correctly on the day of HCG trigger in fresh cycles and on the day before start progesterone supplementation in frozen cycles. Little is known about the possible relationship between endometrial thickness measurement and neonatal birth weight. There are very few studies like Ribeiro et al. In 2018, and they predicted that if endometrial thickness is less than 7 mm, then there is low birth weight. Similarly, Moft et al. In 2017 did a study of 764 neonatal birth weights, and they tried to find out is there any significance of endometrial thickness in predicting neonatal birth weight. So we propose the study to know the predictive value of endometrial thickness measurement in addition to endocrinology before implantation step during ART for neonatal birth weight and live birth rates. So my primary objective is to study the predictor outcome value of ET in IVF cycle on neonatal birth weights measured at the time of birth. And secondary objective is also to compare does it make a significant difference in fresh versus frozen embryo transfer cycle. So I will then compare both of them also, and I will take both of them. Time and place of research is Matatwa IVF Center, and my study will be a follow-up of a retrospective study with prospective cohort study, and we'll take data from January 2019 to June 2021 till my study, my course will go on, and the study approval will be taken from Independent Ethical Committee of IFS. The patient will be selected for IVF or FET at our center, and we will take retrospective data as well as prospective. The patient will be aged between 25 to 40 years with BMI less than 30. They will be screened for exclusion criteria, and then eligible patients will be recruited. Inclusion criteria, as already I told, 25 to 40 years will be the age, and BMI will be less than 30. And we will not take patients with endometrial disease like genital TB that because affects the ET otherwise also, ovarian cyst or masses, endometriosis, abnormal uterine cavity like Asherman, and with active pelvic infections and with more than one myomas larger than 3 centimeters. So clinical protocol will be a retrospective data with, and we will recruit all new patients also taken for IVF or FET cycles, and we'll note age, BMI, and ET done by 2D scan that resulted in successful pregnancy. Then we will follow them for antenatal details like birth weight of the neonate at that time of birth and obstetrical complication, if any, it will be noted. And my sample size will be minimum of 100 patients, including retrospective and prospective study. Methodology will be, we will follow the standard antagonist protocol with recombinant gonadotropin or HMG as a stimulation protocol. TVS will be done every other day, starting from 6th day of stimulation till achievement of HCG trigger. We'll use the centers and evolution S8 machine. At the day of HCG triggering, we'll see ED, endometrial thickness, and it will measure in longitudinal plane at the widest anterior-posterior diameter with transvaginal 2D scan 1 centimeter below the fundus. And all the measurement will be done 3 times by the same examiner, and the mean will be recorded. Similarly, for frozen cycles, we'll take oral estrogen therapy to prime the endometrium for a maximum of 12 to 14 days, and then ET will be measured before starting progesterone in the same manner as in fresh cycles. Embryo will be transferred in 2 stages at cleavage stage or blastocyst stage with a partially filled bladder under guidance of transabdominal ultrasound, and luteal phase support was given as per our standard protocol. And this is the flow chart for that recruitment and retrospective data. Then we will follow for prospective in the same headings. Eligible patient will be taken, 2D scan will be done on the 2 specific days. Then we'll note maternal age, BMI, neonatal birth weight, and birth rate records. And then statistical analysis will be done. Primary parameter, endometrial thickness is maximum anterior posterior diameter between endometrial layers about 1 centimeter from the uterine fundus by USG visualization. Birth weight will be live born unit beyond 28 weeks of gestational age, measured at the time of birth. Clinical pregnancy rate, we will see ultrasonic visualization of gestational segment, cardiac activity, it will be taken, and live birth rate will be delivery of a live born unit beyond 28 weeks of gestation. Other parameters that we are going to study or take will be age, BMI, what is the cause of infertility, hormonal profile, primary or secondary infertility, years of infertility, number of embryo transfers, and patient handwritten records. Coming to the statistical analysis, so the ET will subdivide the group in 3, less than 8 mm, 8 to 10 mm, and 10 mm or more. Then univariate regression analysis will be performed between ET and neonatal birth weight to evaluate what is the degree of correlation between these two variables for each of the group. And we have to do multiple linear regression analysis also, because there are many factors like age, BMI, and even gestational age that can also affect the birth weight. So we will see all of them, how they are affecting, or are they affecting our outcome or not. So this will be the tables in which I am going to complete my data for the study, the EMT groups, the age, the BMI, number of embryo transfers, infertility duration, period of gestation, and gender. A value less than 0.5, as all of us know, will be considered significant. Similarly, second thing that I'm going to study is how is there any difference in fresh and frozen or not? Because many studies are doing either fresh, some are doing frozen. So I want to see is there any difference or not. Now, and last is Fisher exact test that I need to do, because I am doing, I will divide my study in 2 groups again, low birth weight or normal birth weight, and ET less than 8 mm or more than 8 mm. So it will be bivariate thing. And so Fisher exact test will be done to know is there any correlation or any relation between them truly or not. So my expected outcome will be if there any predictive value of performing EMT measurement in addition to endocrinology test prior to implantation for assessing neonatal birth weight. Lacunae is because of COVID, we have less patient. So we are taking retrospective data, and 100 is the minimum number, and we are planning to take more of the data if possible. Thank you everyone for patient listening.
Thank you, Dr. Harpreet. Now I would request the experts to give their expert comments.
Dr. Neena, you want to go first?
Yeah, I think a really interesting study, because we, as she's pointed out in the review literature, there are very limited data, and I think it calls for, a thought that EMT could be related to. There are just few concerns that I have, since she's considering retrospective as well as prospective. And I think she's very clearly mentioned the methodology, the observer will be the same. That was my concern, because, we've considering the pandemic and she's doing her diploma, so time essence is there. But there's one thing that I want to ask her, and that is what I think needs to be elaborated on her inclusion criteria, particularly when you're talking of neonatal birth, birth weight, that's the issue. What is the number of embryos she's putting back? Because you know what, a neonatal weight will be different if it's a twin as an outcome.
Yeah, sorry, I missed it. I will take singleton pregnancy for that.
So, no, but how many embryos you're putting up? That means you're going in for all single embryo transfers. That's what you want to know.
No, I will go.
So how can you take singleton birth? If you're putting back 2 embryos or 3 embryos and you land up with a triplet, so where will you? So will you exclude that? So you'll have to really be clear on that, because neonatal outcome is neonatal birth weight. It's not the neonatal gestation that we're doing that is affected. And the second thing is that you mentioned about cleavage as well as blastocyst. Again, you'll have to have subgroups, because the birth weight would vary between a cleavage embryo implanting versus a blastocyst implanting. And there's sufficient data there. We have got a lot of data on the perinatal outcomes there. So I think, again, not only in the number, I would like to know that you have to be very clear and specific on the quality of embryo you're putting, because you're putting back, are you comparing fresh versus frozen? There's a lot of data between fresh, frozen. We already know frozen embryo transfers, what is the outcome. But if you're correlating that with the endometrial thickness, which is another paradigm that you are adding to your study, I think we need to be clear again on the quality of the embryos, both fresh and fresh. It's not just the number, it will be quality again, because quality term will determine, the grading will also determine the kind of birth weight that we have. Now, my only thing is about the bit of the retrospective and the prospective. I think on the ethics, you cleared it because, but if you're going in for a meaningful publication, because 100 is a small number, and as you said, you committed to minimum, but if you go further,
but I will try.
that could be. But then my only concern is that when you amalgamate data like this, what about the many biases that would arise? Because it's not just the bias on the person who's doing the endometrial thickness, there'll be many other confounders on your data as well. So that is one thing that I would want, and you should kind of rectify these things and put these things in the, because that would make an impact on the, study.
Okay, I'll do that. I'll discuss with Dr. Sudha and then we'll change it.
Yeah.
Yeah. Thank you.
I would request the other experts to give the comments.
Roma, yeah, okay. So Harpreet, I congratulate you. I think it's a very valid question that you wish to study. But
Yes.
I feel like a GP sitting in, the August gathering of experts, the ART experts. So I have a very different take on this study. You see, you are wanting to assess the outcome, the neonatal weight in relation to the endometrial receptivity. Point well taken. But I feel, and it is known, it's not what I feel. We know that the outcome, the neonatal birth weight, has so many factors that affect it, isn't it? Starting from the medical disorders.
Yes,
Did
then
you
when I was
factor for the
yeah, I will exclude the diabetic patients and PIH also. I have to exclude because that also affects neonatal birth.
collagen disorders,
Yes.
vasculopathies,
That
so
I
many
have
things
to
are there.
take. Yeah. When I was taking this, so I was bothered about that beforehand. It's lots of factor will affect neonatal birth weight, but I'll try to exclude them.
I think you need to go into the literature a little more and just see, what exactly are important. Because once you start excluding,
Yes.
especially since you're taking women of such a wide range, you may not get, especially if you're wanting to do a prospective aspect, a prospective arm, and a COVID era, and then the exclusion, majority of the ladies will get excluded because of the medical disorders which are present before pregnancy, and then those which are associated with pregnancy.
Yes.
So I would suggest that you give it a deep thought, because this is one of the major confounding factors that I find in your study. Number two, do you think the maternal age also affects the type, the embryo, the ovum, and thereby the development of the embryo? Do you think that could itself be a variable
Ma'am, in
affecting
previous studies, whatever I studies in some of the old literature, in Chinese studies also, they said age is not affecting that much, so it cannot be a valid confounding factor. So we can take a range between 25 to 40. Because
You
they
give
said
it a
there is
thought. You see, I'm not an expert in this area, so I just wanted to, draw your attention in that direction. And if you think, and because as a person, I feel, this is what we have been reading all throughout, that as the mother grew and the father too. So as they grow older, the ova do get affected. So if it also affects the growth of the neonate, and if it affects the outcome, that needs to be addressed.
Yeah, that I will see more
Yeah,
studies.
and another point regarding what Dr. Neena had asked you regarding the outcome, say triplets. So, do you think it's a good idea to then compare it with the nomogram for our country for the weight that would normally be
Then
there
we will
for the
adjust
triplets?
that gestational age and single versus twin.
Yeah.
We have to adjust that in our final result.
Which you can put in your research protocol, isn't it?
Yes, I will.
Because I am sure the number of preterm births and the
Yes,
multiple
gestational age,
pregnancies.
definitely I will adjust to see the birth weights and how at this age, what should be the birth weight and what I am getting from my data, that I need to adjust.
Right. So one is the gestational age, and the
Yes.
second is the multiple
Multiple
pregnancies.
pregnancies, yes.
And the third factor is the maternal age, followed by the maternal complications, the medical disorders.
Yes, and
So
we
you,
transfers to embryo only. That is that we decided only to
whatever,
embryo.
I think you need to just step back, take these points. Probably you could note them, because
Yeah, I'm
when we
noting.
are talking in the public, much of it doesn't get assimilated. So it's a good study. I think it's a valid point to study. But the point is, you just need to address these points. And I
Okay.
would also agree with Dr. Neena, the prospective arm and the retrospective. It's not very clear at all, the methodology. How do you plan to address the issues? And in case you say 100, what is the timeline? Because the procedures have changed. You see, what happened about 2 or 3 years back is not what it used to be earlier. So the
No,
way you process the embryo, so does that also affect your outcome? The way endometrium was measured and whatever, you can just see the methodology. If the factors are the same, if they don't affect your study, probably you could give a timeline. Retrospective 100 samples or 50 samples over this period of time with the same kind of criteria applied to the selection and receptivity, all those kind of points that need to be addressed. Okay.
That I mentioned, ma'am, January 2019 to June 2021, and with Dr. Sudha only, all the cases of her. So we'll do in that ways we are time frame the study, not beyond that.
Okay, so then how much is the retrospective sample size and what is the prospective? Harpreet,
yes,
you
ma'am.
please note down these points and you can address them.
Yes,
Okay?
yes.
Yeah, you may not remember offhand all the values.
Yeah, yes, ma'am.
So I am fine with that. I just want to, draw your attention. Okay. So thank you so much.
Thank you so much.
Harpreet, I think all points have been addressed largely. I appreciate your study ideas. It's interesting to know whether endometrial thickness is at all linked to birth weights. I have just one input apart from what has already been stated. It is with the statistical analysis of your data. And at some point you make that distinction between less than 8 and more than 8 and try to link it to that. And I mean, there's a wealth of literature out there that says that, we don't have a thickness which would determine outcome yet. So to begin with, when you are first trying to correlate this, I would suggest that you find a cutoff, if at all. One, if it correlates. Two, if it does, what is that cutoff that would lower the birth weight? Okay. Now, it's difficult to do that based on both of these are what we would call continuous variables. Okay. So a simple analysis is looking at Pearson's correlation coefficient, and anything more than, you could say, a moderate correlation would be between 0.3 and 0.5. So if you establish that, now you want to know the effect of confounders, the 5 or 6 that have already been stated. You put that into what is known as a multiple linear regression. You've already got that, okay, and you find that this is still significant. Then you try and establish a cutoff by dividing your outcome into a binary variable. I can't see you. Oh, where are you? I can't see you on the screen. Okay, anyways. So by dividing your outcome into a binary variable, and the binary variable is neonatal birth weight appropriate for gestational age, or less than gestational age, okay? And your endometrial thickness remains continuous. So you do an ROC and try and see if there is a cutoff at all or not. I don't see the point of a Fisher's exact test at this point, not without establishing your cutoff. First is correlation, establish a correlation as a univariate analysis, then through giving a linear regression. If it's still relating, then you try and establish a cutoff. And again, the numbers might be too low for you to prove anything. If it is a retrospective analysis, I think there's no limit to how back you can go in terms of picking up the numbers. But I would think Dr. Radhika has a point there in saying that time would determine policies and that change with time. So maybe what you're doing, as at least as a learning exercise.
I'll stick mainly first to univariate and multiple regression analysis.
Yeah.
Then we'll see if we're able to or not.
Yeah. Okay.
Okay. Thank you.
Thank you, experts. Now, I would like to invite our second study presenter, Dr. Harmanjot Kaur. She is affiliated to MIT Institute of Molecular Medicine and Stem Cell Research, MIT University, Noida, and for the Diploma in Clinical Embryology. And the title of her study presentation is Impact of Warming of Vitrified Semen at Different Temperatures in Cryo Survival. Over to you, Dr. Harmanjot.
Yes, thank you, ma'am. Ma'am, is my screen available?
Yeah. Make it full screen.
Okay, ma'am.
Yeah.
So, very good morning to everyone. The thesis, the topic of protocol for my the study protocol topic is Impact of warming of vitrified semen at different temperatures on cryosurvival. First, coming to introduction, we know that sperm cryopreservation is an efficient method of preserving male fertility. And basically, there are two ruling methods for sperm cryopreservation. Those are slow freezing and vitrification. Vitrification has been proven to be most fast, easy, and cost-effective method than slow freezing. And moreover, it prevents the sperm cryo injuries better. But there is absence of a promising protocol for optimal warming of vitrified sperm, and still slow freezing is a preferred technique used by various laboratories and sperm banks for sperm cryopreservation. Therefore, our study is being conducted to know about optimum warming temperature for human vitrified sperm. Coming to a brief review of literature, the study shown here by Lee et al., he conducted a comparative study of slow freezing and vitrification on 105 samples, which ultimately concluded that vitrification gave morphologically healthier sperms rather than slow freezing. And when meta-analysis were performed by Zhu et al., he also concluded that vitrification in post-warm motility was superior to traditional freezing. So vitrification was better, we know. But in literature, our article given by Sanchez et al. Mentioned that for proper functioning of sperm and for proper maintaining the membrane integrity of sperm, optimum devitrification of temperature is also important, and that is what we are focusing on in our study. The various authors have shown that they have vitrified their sperm sample at different temperatures, like Ali Muhammad at 42 degrees Celsius, Pavlin et al. At 44 degrees Celsius, Nguyen et al. At 37 degrees Celsius. So there is not any particular optimum temperature where we can thaw or where we can warm vitrified sperm. Therefore, our aim and objective is to determine the optimum warming protocol for vitrified human sperm by comparing the post-warming parameters at different temperatures. Coming to methodology, first, we will recruit the cases. We will collect the semen samples. Their fresh sample semen parameters will be analyzed by CASA system. Then the vitrification of sample will be done, and then the warming of sample at different temperature. Then we will analyze the post-warm semen parameters. Now, briefly discussing each of these. First, coming to recruitment of cases. This is our prospective study, and which will be conducted at Jindal IVF St. Memorial Nursing Home, Chandigarh, over the period of 3 months, that is from 1st November to 31st January 2021. The total 100 patients will be recruited. Those will be coming for backup for IUI preparation or semen analysis, age 25 to 50 years. Our inclusion criteria includes the subjects having a raw semen parameter values above the lower limits of WHO 2010 criteria, and those who agreed to sign the informed consent. The exclusion criteria includes those patients, those are positive for hepatitis B surface antigen, hepatitis C virus, HIV 1 and 2, and VDRL test, which is a blood test for syphilis, and COVID-19. So the patients with our inclusion criteria, their semen sample will be collected in a well-labeled sterile wide mouth container. Those will be having 2 to 3 days of sexual abstinence. And then after liquefaction, their fresh semen sample parameters will be analyzed by CASA. Coming to vitrification protocol. First, initial warming of cryoprotectant will be done at 37 degrees Celsius. Then 1 ml of cryoprotectant will be added to 1 ml of semen sample in a test tube, drop by drop. Then the mixed sample will be kept at 37 degrees Celsius for 10 minutes. And mixed sample will be transferred to 3 well-labeled cryo vials. Those will be dipped into liquid nitrogen held in a foam box as shown here in diagram. And by the help of Pasteur's pipette, will transfer the sample and finally plunge it into liquid nitrogen. Coming to the warming protocol, the sample will be placed at 3 different temperatures for 5 minutes first, that is at room temperature, at 37 degrees Celsius, at 42 degrees Celsius. Then we will incubate the sample at 37 degrees Celsius for 30 minutes. And finally, we will analyze the post-thaw semen parameters. As I told that we will analyze fresh semen parameters and post-thaw semen parameters. So parameters which we will be recording by CASA system are count, motility, progressive motility, kinematics, which include curvilinear velocity, average path velocity, straight linear velocity, linearity, wobble, and straightness. The endpoints of our study will be percentage survival of motile sperm, which will be calculated as by cryosurvival factor, which is post-thaw motility by pre-freeze motility into 100, and kinematics, which will be compared at different warming temperatures. The statistical analysis will be done by using SPS22 applying ANOVA. We'll be keeping our p-value less than or equal to 0.05, and then the post-warming parameters of each different temperatures will be compared to one another as well as with the pre-freeze parameters. And finally, we will analyze what is the optimum warming temperature for human vitrified sperm. Thank you.
Thank you, Dr. Harman.
Thank you.
Now I would request the experts to give their expert comments.
So I think it's a very well thought, protocol, because I think vitrification on sperms is really tricky, and I think she's made her inclusion criteria very clear, and also as exclusion. And I think the timelines are well defined. I just would say I'm not a embryologist, but only one concern I have, because you're looking at, you're trying to identify the temperature which suits best for warming. That's really the that's the aim, that we wanted to know which temperature suits best when we are warming the vitrified sperms at the 3 temperatures you find. Now, I don't understand what you mean by room temperature, because you're freezing them. You're given a timeline for freezing, which is i.e. beginning 1st of November and going on till some 3 months later. You're going to vitrify them for whatever time, but then the temperature, room temperature is going to vary. So, I mean, again, here, can you sort of be defining? You have to give a little bit of number. Why you're giving 37 degrees, 42 degrees. What do you mean by room temperature? I want to know, because it'll be varying between Chandigarh to Delhi or any place. And
in our laboratory, ma'am, we basically maintain the temperature. In our laboratory, we maintain temperature from 22 to 24 degrees Celsius.
So then mention 22 to 24 rather than use a term like room temperature, because a room temperature would be very different from a place to place. So I think why don't you come on that? That's your ambient temperature of the lab. That's what you mean.
Okay, ma'am.
That rather than use a room temperature. That's what, because to me it doesn't make logic trying putting just room temperature, and July would be a room temperature. So I think in terms of embryology, I think be specific. Otherwise, I think it's well written, and I really don't have much to sort of comment in the methodology and inclusion.
Harpreet, can I see your title slide, please? And can I see your last but one before the thank you slide? So I think I missed it somewhere down the line. Are you going to warm the same sample at different temperatures and compare?
Yes, ma'am. We are transferring the same sample into 3 different vials, so that afterwards we can warm it at 3 different temperatures.
Okay. So would you be doing something standard also? How do you plan to, what is your standard for comparison?
Sorry, ma'am. Standard.
How do you plan? Yeah. What is the current standard? What is the established? Is there a gold standard for the present?
Ma'am, actually, I'm not getting what are you going.
अभी जिस तरीके से आप कर रहे हैं, है ना? अभी जो आप vitrified semen को warm कर रहे हैं, है ना? For usage. What is the current technique?
Ma'am, actually, we are using yet slow freezing. Vitrification is not, as I told, that vitrification, although it has been proved that it is better technique, but still many centers.
Slow freezing, that's okay. Slow freezing के बाद, before you wish to use it, what is the current system of warming up the semen?
Ma'am, first we are keeping it at room temperature for 10 minutes. Then we used to place it at 37 degrees Celsius for next 30 minutes.
Outcome, उसका कितना percentage outcome है? कितने usable sperms आ जाते हैं उसमें?
Ma'am, it depends upon sample to sample.
Exactly.
How much, if it is a good sample.
Yeah, so that is exactly what I'm trying to drive home. So it
Hanji.
starts with the initial seed, isn't it? The initial sample that
ma'am.
you're using.
Yes,
so
ma'am.
now in your study, what I find is there are two variables. एक तो आपका जो beginning का जो semen sample है, वो it largely determines the outcome of your study, number one. And on that, you have added 3 types of temperatures to get the final harvest.
Ma'am, but we are taking the lower limits. The sample must be above the lower limits of WHO criteria. So
you
it
tell
will
me
be a
one
good
thing.
sample.
That's okay. So what is that single one parameter which determines the outcome of your worming? Is it the
Motility? It is motility.
The motility, or is it the, and what kind of motility? You know, does it matter whether if it is a slowly motile, if it is
No,
grade
ma'am.
3,
It
grade 4?
mainly progressive motility.
Okay. And what about other factors? Okay. So it is basically the motility which determines, isn't
Yes,
it?
ma'am.
So
Yes,
now what are you going to compare your outcome with? Are you going to compare with the established standard that the world is practicing, that is room temperature? Are you going to compare the outcome with the 3 temperatures that you're planning to use with the existing standard?
Ma'am, we are going to first we'll come to know about the pre-freeze, what actually it was. Then afterward we will
ठीक है, वो हम
come to
समझ गए आपकी बात. मैं तो ये जानना
हाँ
चाह
जी.
रही हूँ कि आपके हाथ में जो भी चीज आती है, आप उसको खराब या बेटर कैसे बताने वाली हो? You are going to compare it with what?
What, ma'am? We are going to compare it between three temperatures. Out of 3 temperatures, we will get to know which at what temperature we are getting the higher motility.
ठीक है. So तीनों ही experimental है ना?
हाँ जी.
So because what is your sample size?
Ma'am, 100.
Okay, so we don't know. That means, are you going to divide the 3 into equal numbers? How is it going to be? What is your methodology? And it's not yet clear to me that what is your comparison? आपने 3 experimental values डाल दिए उसमें, आप उसको किसके साथ compare कर रहे हो?
Excuse me, I am the guide. Madam,
Yeah.
let me explain.
Yeah,
We
please.
are freezing the sample in 3 vials, and we are warming 1 vial at room temperature, second vial at 37 degree, and third vial at 42 degree. So we are comparing the outcome. We are freezing the same sample in 3 ways. We are warming the same sample in 3 ways because we have frozen in 3 vials. So we are comparing the results of these 3 warming temperatures.
Fine. So the current method is room temperature as it is,
Yes.
isn't it? So the comparison is with the room temperature and the 2 different temperatures that you're using to warm the sperms.
Yes, madam. In current conventional freezing, we dip the semen sample from minus
Dr.
70 degree.
Sandeep, मैं वो बात समझ गई. I completely understand the way you
Yes.
freeze it and all that. No?
Because
Your point of study is how to warm them.
Yes,
so
ma'am.
let's focus on that. So now it's
Yes.
clear to me that you are using one standard and 2 different temperatures, isn't it?
Yes, ma'am. Yes, ma'am.
So do you think it also affects your cost and the time and all that? Do you want to also include some cost analysis in this? Does it affect your thing to warm up? Do you need anything different?
Madam,
Room
it's-
temperature
No,
is just keeping it out, isn't it?
Yes, ma'am.
So how do you plan to warm it, and does it affect? Does it require any kind of extra paraphernalia which affects the cost? Because I feel ART always, anything you add, it increases the cost. So it's just just consider me blank on this. I just want your answer on this.
Madam, if we are able to find a good temperature at warming, probably we will be saving so much time in vitrification,
Right.
more than slow freezing. If we are able to vitrify, we will be able to save a good time, and that will cover all the costs.
Okay. So there is an additional cost, that means, is it?
Definitely, madam, we are freezing in 3
Oh.
vials. Definitely 3. We need to almost 3 times of the cryoprotectant and all that.
Okay,
But
that
if-
is because of the experiment. But once you get a final data, then
Call-
I think that should be fine.
We
isn't
will
it?
go back
Yes,
to
ma'am.
single
Okay,
freeze.
fine. So that's it. Thank you so much.
Thank you.
Dr. Ruma?
Yeah, hi, Harman. I have just 2 comments to make. While going through your study proposal, your literature review was stretched over 3 pages, and the literature review was largely a comparison of slow freezing versus vitrification. And somewhere your experiment, what you're trying to prove, that warming temperatures might matter in percentage motility, post-thaw motility, does not come through. It only sort of appears in the last 4 lines. So I think that could be modified a little so that, you know, when you finally give it for publication, it's easier for reviewers to understand what the study is about. So I take your point of mentioning that vitrification is a better method, needs to be improved upon, but do not go writing pages over pages on just a comparison between vitrification and slow freezing.
Ma'am, actually, there is not much study done in literature about optimal warming, so that is why.
Doesn't matter. So you don't have to write several pages. You have to drive home the point that vitrification is a better technology, okay, based on these studies. Second is that we don't yet know the right warming temperature, and which is why we are taking this study up. Okay, that's one.
Okay, ma'am.
Second is I understand that this is an experiment, and I only learned of it through your presentation. Somehow while reading your proposal, I wasn't clear about whether this sperm sample would be used in patients at all or not, or you end it here after studying your results. Would you be using these vials clinically? Through this, after you warm it at different temperatures, would you be using the semen sample for any clinical purpose?
Sorry, ma'am, your voice was not audible. Could you repeat, please?
Yeah, I'm saying, Herman, I'm not clear if the semen sample, the thawed semen sample would be used clinically. This bit is not clear to me. After you have warmed it at 3 different temperatures.
Yes, ma'am.
So the thawed semen sample, would you be using it for any clinical?
No, ma'am. No, ma'am.
You wouldn't be. Okay.
No, ma'am.
Right, because then it becomes ethically, a bit of an issue. I think that's all from my side. The rest of the concerns have been addressed.
Okay, ma'am. Thank you.
Thank you, experts. Dr. Herman, you can stop sharing your screen.
Okay, ma'am.
Now I would like to introduce our third study presenter, Dr. Kumkum Rana. She is fellow in clinical ART IFS. Her study is titled Maternal Age and its Impact on Implantation and Clinical Pregnancy Rates in Patients Undergoing Day 3 versus Day 5 Embryo Transfer in Indian Population. Dr. Kumkum Rana, are you here? Dr. Kumkum? Dr. Kumkum, are you here?
Okay.
I think she has not joined yet.
But there is one device which is not identified by a name. I don't know, 73EC291F. Is that Kumkum? Okay, maybe she's not there. So
yeah, Tanvi has called me. She has not joined. She has not seen in participants or faculty.
All right. We are actually 20 minutes ahead of schedule.
In fact, her protocol was the one which really needed a discussion.
Yeah, Dr. Kumkum's, yeah.
Yeah, that was, I thought we'd have a lot of discussion because on the objectives and the methodology that I read, I think that was the one which was, she's comparing maternal ages with the outcome. I think it would have been more meaningful for her to be here because the inputs could have been useful for her rectifying her things anyway.
What should we do? Should we proceed ahead?
Okay, for the next sessions rather than.
Ahmed, would you like to say something about the studies so far discussed?
See, I like the design of the previous study is good. That is something that has to be looked at whenever you're looking at an andrology study. That is, you split the same sample and you follow up the same. That's a very good selection, I would say, of population. And I think, yes, you pointed out that's correct. Introduction and coming to the question is very important. So you don't go around comparing slow freeze, vitrification. You just straight go to vitrification and what was the basis for the current practice and then move on and try to show. So I think the group is trying to show what's the standard and then comparing with 2 temperatures. That's fine. I don't see any extra cost. Probably room ambient temperature you might have to change by your air conditioning. I had comments on the previous study, that the endometrial thickness one, which is a bit of a concern. I think Dr. Neena has given a long list and I would just add, like, I think there's so many confounders. So the noise in the design is so much that it's going to be very difficult to identify because the confounders are just too many, and the outcome is way down, the downstream, it's way down. So there'll be just too many confounders for that. Starting with how you measure it, it will be intra-observer variation also. I sometimes measure 7, sometimes I measure 8, and that's going to create a lot of things. Third is that, what are we gaining out of the whole exercise is very important. So how is it going to really change anything once we're done? Like, let's say I find a slightly higher, probably a lower neonatal weight. There again, there's a problem. So at 7 mm, if I find, what does it mean to me in practice? Because we do so much of effort, and eventually what is going to change down the stream is very important. And of course, those are the things. And fourth is, how are you going to decide who's going to deliver at what point? So that again, the obstetric guidelines have to be very uniform. The patient might deliver in another hospital where the consultant feels in a very different way. So that will be a big confounder here. So I think there's just too many confounders, and there has to be some uniformity. So probably my advice would be to stick to either frozen or fresh or something like that, more towards frozen, so that at least some homogeneity comes in. That's what I would look. But neonatal outcomes, like the recently, even the indications of IVF will have an impact on neonatal outcomes. And Dr. Nina did point out that I think the candidate has to pick up that even if you have a singleton following 2 embryos or 3 embryos, you have a vanishing twin phenomena, and that can have an impact. So there's just too many confounders, which for a small sample size might have an impact. So those are my comments for the previous study. I think I would stop at that. Yeah.
Ms. Kumkum is not here. Do we move on to the next session?
Yeah, I think that's
mean that
Dr. Nina, any suggestions? Yeah.
Thank you so much for having us in. I think we can probably sort of call her, and if Kumkum is not turning up, not showing up, we can move because.
Yeah, that's fine.
Yeah,
We can have a more discussions on the next session. Yeah, with more active participation from everybody. Yeah.
Thank you so much, Ruma. Mohan, thank you so much.
Thank you, ma'am. Thank you for making it. We benefit from your inputs every time.
That's so nice of you. Thank you so much. Bye.
Thank you, experts.
Dr. Divya, Dr. Shalini would be joining in a little while. She's in an emergency. The next session chairperson.
The MOC can introduce whoever the chairperson. Yeah. Whoever is available. Yes.
Yeah, that's Dr. Divya. I think her connection is cut off again.
Okay.
Dr. Divya?
Yeah, I think it's static.
Okay.
Yeah.
Yeah.
You're there.
Audience, any questions? Nothing. Nobody's asking.
Yeah. To start with the session 4, I'm going to introduce our esteemed chairpersons. First of all, I introduce Dr. Vanita Jain. She is the professor in Department of Obs and Gynae, PGI Medical Institute of Education and Research Center, Chandigarh, and she is a certified robotic surgeon. I also welcome Dr. Deepa Goyal. She is the consultant Anuradha Obs and Gynae Center, Patiala, and she is president of Society of Fetal Medicine, Patiala. Our third chairperson is Dr. Monika Verma. She is the medical director, Sadbhavna IVF and Obs and Gynae Center, Patiala. She is also the former joint secretary of IFS Punjab chapter. Our fourth chairperson is Dr. Shanli. She is the consultant ops and gynae at Yadav Hospital, Nandani IVF and Fertility Center. She is also the visiting consultant at Max Hospital, Gurgaon. I welcome all the chairpersons.
Thank you, Dr. Divya. I would now call upon Dr. Kamath for his talk. I have to introduce him. Everyone knows him. He's been there since morning and giving his inputs. Dr. Kamath is the professor of reproductive medicine at CMC Vellore and is on the is an editorial board member for Cochrane Fertility and Gynecology. He has done his MS from Pune AFMC and postdoctoral fellowship from CMC Vellore and University of Aberdeen, UK, and has more than 75 publications to his credit. He will be speaking on an idea to publication, which we know is a very long road. So he'll be talking about the lessons learned from the idea to the publication. Dr. Kamath, please.
Thank you, ma'am. I'll just open my slides. We are ahead of time by 5 minutes, so I have some more time with me, so that should be okay. My slides are visible as I see?
Yes, yeah. They are.
So this talk is mainly sharing our experience, which I think will resonate with most of us clinicians over here about how simple ideas can be converted into good studies and eventually lead to publication. Though I would, I always stress this, that publication is the final product of the whole journey, and that's not our aim. Our aim here is about solving our patients' problems and clearing up the clinical dilemmas that we face every day in our practice. And that should be our motivation, trying to close the knowledge gaps that are plenty in clinical practice. And all of us understand and know this very well. So starting from there, so I would just, I don't have any conflict of interest generally, but of course, this is a study that we have done. So there will be a talk about that study. So the topic being covered is on how do we get that idea. So I'm just giving an example of our study, but it's also for everybody to think about it, ponder over that point. How did we go about planning the study? What are the biostats requirements when you plan a study? How do we execute it, the problems faced, and so on? And how do we actually end up going through the publication process? Now, this is very crucial. Most of us believe that we are very busy in clinical practice and we don't have time for research. But many of my mentors have told us, and I do believe that being a clinician who is on the ground is a distinct advantage, because you kind of know exactly where the knowledge gaps, what are the clinical dilemmas. I have stressed this. So we face this problem in infertility clinic. That is, we kind of trying to find out in the female partner about their ovulatory status. Then, of course, we have to look at the tubes and uterus and so on. But quite a number of them will have ovulatory dysfunction. Now, we have two groups. One is women with irregular cycles, where it is quite clear that there must be an underlying ovulatory dysfunction. But the regular cycles, the women with regular cycles, where do they stand? Okay. So we know for there is some literature there which kind of tells us that most of the regulatory cycles are ovulatory cycles. But the dilemma here is whether you want to confirm it by doing some test. And more specifically, the test is serum progesterone, mid-luteal progesterone. So this is something that we have been reading right from MBBS through our MD and so on. So the background information we wanted to collect, and we did that. A lot of studies are there. The couple of them referenced here. So they found out the prevalence. Okay, this is a descriptive study. Prevalence was between 3 to 19% for anovulation, anovulatory cycles among women with eumenoric cycles. That is regular cycles. You had anywhere between 3 to 19% cycles were anovulatory. Now, what do the guidelines say? So we don't have an Indian specific guideline. So I had to look at what is the world doing on this. So we had the UK NICE guidelines, which recommends mid-luteal progesterone as a test for ovulation, even in women with regular menstrual cycle. So they were quite clear and they felt that there is a need to confirm ovulation in this group as well. However, the North American guidelines were not so specific and they were more pragmatic, if I would call it. They felt the statement in the practice guideline is menstrual history may all that be required in most of the ovulatory women for menstrual cycles are regular. However, they mention diagnostic workup should assess ovulation, but they do not specify any particular test for ovulation. So this is a very pragmatic guideline, which kind of gives you some leeway as a clinician. And that is what was our starting point. So you can see that two different guidelines have two different views on a particular test. Now it also goes that there is like, we relate to this philosophy of trying to simplify infertility workup, which is actually opposite of what is happening now in current practice, where things are getting more and more complicated with loads of tests being offered to the patient, but we are not really sure if they are adding any value. So our philosophy was, can we avoid this extra test, which is going to cost the patient money, time, inconvenience, of course, and how do we reduce that testing? By just relying on the history. So is the history enough for assessment of ovulatory status in a woman with regular cycles? So the aim for the study was to estimate the prevalence of ovulatory cycle in these women and also assess the reliability of self-reported regular cycles in identifying ovulatory cycles. So remember, I have not put here ovulation. I have only maintained that we are only identifying ovulatory cycles. So the aim leads us to multiple objectives. So we had, usually we'll have one or two objectives. We had three. What we wanted was first a description. Okay, what's the prevalence of ovulatory cycles in these women who are regular, who have regular cycles? We wanted to compare, I would put it as a third outcome. We also wanted to check the positive predictive value of self-reported cycles in identifying ovulatory cycles. That means the women who said they had regular cycles, what was the positive predictive value of that? The third objective was, if at all you want to look at serum progesterone, how does it compare with an ultrasound? We modified this ultrasound assessment by going only by a single well-timed ultrasound as against what we do normally, which is a follicle tracking, which requires multiple visits. So those were the three objectives. Our setting was an OP clinic tertiary level center with fairly large volume of participants, and we kind of zeroed into recruiting local patients who were easier to follow up. We also had, of course, easy access to ultrasound and a reliable biochem lab. Now, this is crucial. This is because we were going into a new area. So all till morning, you have found out about cohort study, case control study, and so on, RCTs. But this was a new area for us, diagnostic tech accuracy study, which has got a lot of scope. So we wanted to try our hand on this. And we started getting familiar with the basic terms. Remember, you have studied all this in your PG and all these terms, but sometimes we don't relate it so easily. You know, it doesn't come to us naturally. So you have to get familiar with each of these terms like sensitivity, specificity, PPV, NPV, negative likelihood ratio, positive likelihood ratio, and so on. There is something called agreement between the diagnostic tests, which is again domain of advanced diagnostic biostats. So we had some biostat support as well. So armed with all this knowledge, we did our background reading. So if you are looking at diagnostic tests, this is one 2x2 table, which should be in your mind. That image should be always flashing in your mind when you're doing any diagnostic test. And we start getting familiar with what is sensitivity, specificity, PPV, NPV. You have to have this working 2x2 table. Okay, disease test plus or minus and so on. But there was another concept which we looked at very closely. What is called, eventually after the doing all this diagnostic tests, there is something called pre-test and post-test probability. The basic bottom line here, what I wanted to stress was that if the probability of the disease were greater than 90%, even before doing the test, then you actually don't need to do that test. In other words, if I give an example of COVID situation, if you have a patient who is a primary contact of a COVID and the patient comes to you with fever and all the classic symptoms of COVID, are you going to really offer a COVID test? But most of the times for medical reason, you don't need to, because you actually know that this guy is COVID, and we are doing that. Many times we just tell them to quarantine and we just wait for symptoms to happen. So the reason is that you are quite sure that this person has the disease. Okay, it's 90% already there. Doing a test is not going to make it 100%. It's just going to climb up from 90 to 95%. That's where it will stand. So these concepts, armed with that, we moved on. So the methodology, we designed a prospective diagnostic accuracy test. Sample size calculation was done based on the serum progesterone sensitivity in the literature, which was 90%. 208 was the participants. Timeline was 6 to 8 months. We, of course, went to the institutional committee and got the approval, written informed consent. Believe me, you have to go through institutional board for any kind of human study. So if you don't have that, your chances of publication drop down dramatically. So remember that for the students. We had one modification, that was single well-timed ultrasound, which we felt could be timed anywhere between the mid-follicular to mid-secretory phase. What we wanted was to document a dominant follicle or a corpus luteum. We are not very particular about tracking a follicle till ovulation. Okay, that's the unique part of this particular design. Why we felt this is important? Because we could then club this with a routine gynecological scan, which is always a part of infertility workup. So you're not doing anything additional. Coming down to actual execution of studies, we actually did not face any major issues. Compliance level was high among the participants. If you look at what happens in the studies, this study did not require participants to really come down for extra visits. The standard tests were involved, so we didn't go for any extra test. And for the recruitment also, we work with shoestring budget. Okay, that's the reality in this part of the world. So our clinicians only and the students have to run around and do this. So they did not have to, spend too much time doing this. They were doing their routine work and they could recruit at the same point of time. This was a part of a postdoc thesis, so the student was involved in that. And of course, we followed up all the cycles by telephone phone call to confirm if the cycle was indeed regular. Results, 208 women, 5% had isolated prolonged cycle, means that the index cycle in that particular group was prolonged. 4% conceived in the same cycle. What we found was, with our ultrasound, we found 98% women actually had ovulatory cycles. If you go to the current standard test, that is serum progesterone, 89%. Positive predictive value for a self-reported history was close to 90 to 98%. That means that if the woman says that her cycles are regular, you're 90 to 98% sure that they're actually ovulatory cycle. And that was the key message that we tried to say. And we compared how did that single ultrasound compare with the serum progesterone, which was the other standard test. This requires sophisticated, little higher form of diagnostic statistics. And our stats came up with something called adjusted kappa, 0.81. Anything beyond 0.80 means perfect, almost perfect agreement. That's the highest level of agreement between the two tests. So conclusion, we found higher prevalence of ovulatory cycles in eumenoric women, making a case for revisiting role of serum progesterone at the test of ovulation. The reliability of self-reported cycles was pretty high. Indeed, if the clinician or the patient were very anxious to document an ovulatory cycle, all they needed to do was time their ultrasound, which was anyway a part of workup, little more, it offers a lot more flexibility. So time it in a way that you can document one of the many parameters that we had suggested. So once we're done with the study, we moved on and we aimed for a high impact journal. So our suggestion is, whenever you finish a study, aim for a higher impact journal from where you think it will fit in, because you will get good constructive comments and you can move on. So we aimed for human reproduction, but faced rejection. Okay. Now, more worryingly, it did not reach the peer review also. Normally, if your article reaches peer review, it's a good sign, means that the editor has felt that there is some merit in the case. However, there was a comment that was there from the editorial that the research question is valid, but they were not convinced about the sample size. Okay, so this is disappointing that happens and we have to face this rejection all the time. It's a part and parcel of life. But we moved on and actually we went to the next higher level. In fact, this is the currently the highest impact factor journal in reproductive medicine, fertility, sterility. We got into peer review and we had very favorable comments. The comments were like this: relevant and interesting study. They just suggested broad refinements in terms of how the criteria were and so on and so forth. And they asked us for a sensitivity analysis. That means we had taken 3 nanograms as a cutoff. They also wanted us to give the results when serum progesterone cutoff was greater than 5. They also mentioned to add findings of a biosite study, which is from the US, and it's a very good study, which is a landmark study in itself. And I could make out that the authors, the reviewers were from this group. The AE's comments were very encouraging to us. The reviewers and I are impressed with the quality of study and believe that it provides confirmatory data to the oft-stated but little cited maxim that human area equals ovulation. So this was the message and we were really excited because it's kind of a validation of what we think is right. Finally, this study got published, and to add to that, what happened was the editorial commentary came along with this. So the commentary was from the group which did the lot of work in ovulation, and they felt that actually they agreed with our findings, and they also quoted their own study wherein even in a regularly ovulating lady, if you document anovulation one cycle, that does not really affect fecundity. Because we need to remember that when we do test of ovulation, it is only telling the story of that particular cycle and not the entire journey. So that is something that we also agree on. So coming to the closing comments, what did we learn? A good idea. So my message here is that you need to have a good idea first, and that requires a lot of time and energy, because you don't get good ideas which have not been touched upon by others. Most of the people across the world are looking at a research question, and most have already done it. Doing studies which have already had an answer is not a good suggestion. Then, as I said, busy OPDs mean more ideas. You kind of take a pause and think, okay, I'm not able to give a clear answer to my patient. Let me go back and check, and you find literature, there's nothing to guide you. And then you decide to launch a study. So also our study was based on a patient-centric study. It's a question that the patient wants to know, and we make their lives easier. So that's the guiding principle of a research question. Other message which we even tried to give in the morning was you don't need to have randomized control trials each time for publication, or trying something very big which is very difficult to implement. You have simple ideas, good science, and you can deliver with shoestring budget as well. But research question is important. Other thing is, one important point is we kind of restrict ourselves to case, cohort study, and RCTs and all. But it's quite possible that we need to master different study designs. Each of them is a challenge. It takes time. You make those baby steps towards each of these designs, get familiar with it. And as I said, you need to do your homework. You need to get familiarized with all the biostat terms and the principles of those designs before you launch it. And that's why, like in morning, we had a retrospective study and we wanted the biostats part to be clarified. So this is how it goes. You can't just jump into a study and then figure out that we don't know the biostat terms. Also, be very clear. The world has moved on in terms of research, and they are now very strict about regulatory norms. So we followed the exact norms. I would like to caution, like many of us are doing randomized trials. Prospective random registration with clinical trial, if you don't have, it will not be even accepted for submission anymore. So, and it's a requirement for us. So please be very clear. Ethics, valid data, all this has become very important in research now, and most of the journals are now being very particular about these things. So that's something that we need to look at. I would stop here and be happy to take questions. Of course, at the end, if it's fine.
Thank you, Dr. Kamath. A very informative talk. And what was very interesting is that it is a very simple idea, but clinically relevant.
Yes.
And there is no dearth of such ideas. So you have given a very good example. I hope it clarifies to the young researchers as to how to go about a study.
Okay. I think Shesh needs to join. Who's looking after this?
Yeah.
Shesh is here.
May I request Dr. Deepa Goyal to introduce our next speaker, Dr. Shesh Kamal Sunkara.
No, she's just
I'm
joined.
pleased,
Yeah.
I'm pleased to introduce Dr. S.K. Sunkara. She's a senior lecturer in reproductive medicine, King's College, London, consultant gynecologist and subspecialist in reproductive medicine, King's Fertility Center, UK. Associate editor for Human Reproduction Update Current, and have been the associate editor for the Human Reproduction previous years from 2014 to 18. Her expertise has been ranked in top 0.34% of 70,000 published authors worldwide in fertility. So that's a great feat. Today she is going to talk on what do peer reviewers look for. Hand over to Dr. Sunkara, please.
Dr. Sunkara.
Ma'am, we can see your slides, but you're not audible.
Dr. Sunkara.
Unmute, start video. Can you hear me now?
Yes.
Yeah.
Sorry about that. Let me open up my slides.
6:30 in the morning in UK. Yeah.
Yeah. How can I not get up for Mohan Kamath?
Thanks.
I will not be forgiven. Good morning or good day to everybody. Dr. Goyal, thank you very much for the kind introduction. And Mohan, thank you very much for having me in this workshop. I did hear parts of it, although I fell asleep in between, but now I'm awake fully because it's quite stimulating. Can you hear me well? I hope I can be heard well.
Yeah, please share your screen, Dr. Sunkara.
Oh, have I not shared my screen? Apologies. I think I shared my screen, but I will do that now. Why is it? Application window. Share. Let me start again. Share screen. Application window. Why is it? Just a second. I will do that now. Apologies. Is that better?
Yeah.
Yeah. Okay. So before I start, probably this is like a concluding session, I would assume, because you've heard a lot throughout the workshop. Before, I thought I would just go through the publishing process in scientific journals. So let us start from the left-hand corner of the slide. So the first process is 1 and 2, when you submit the manuscript. So when a manuscript is submitted, it goes to the editorial team. What the editorial team does is looks through the manuscript, reads the manuscript and see if it fits into the scope of the journal, and also looks at other things like formatting, whether the authors have followed the guidelines for that specific journal in the way it is written and presented. And once it is through that stage, then it is passed on to the editor-in-chief. Usually, the editor-in-chief also has a first glance and then again does a similar exercise to see if this is fit for the journal. And then this is usually allocated to another editor, an associate editor, who has expertise in that particular area. Reproductive medicine, I'm talking within our field, is broad. And so if therefore the editor-in-chief is chosen based on the expertise in that very specific area. So the editor-in-chief then goes through this manuscript. That's where I come in most of the times. And the editor-in-chief decides whether this is good enough to be sent for peer review or it is rejected at that stage. So it can be rejected at 3 stages now. So the first is editorial team, the second managing editor, the second is editor-in-chief, and the third is the AE, associate editor, who can reject it at this stage. It can also be accepted at the various stages, and whereby the associate editor also thinks it is suitable and then sends it for peer review. So usually it is sent off to 2 to 3 peer reviewers. It is difficult to find peer reviewers experts. So probably 2 peer reviewers, and the peer reviewers, they give their comments, which we'll go through in the next in the lecture, what they look for, and they come back to the associate editor with comments to the author, confidential comments to the associate editor, which the authors cannot see, and if sometimes, not always, there are confidential remarks to the associate editor. And based on that, the associate editor puts everything together from all the reviewers who have submitted and then makes a decision, makes the decisions again to reject or to revise. And then, you would be very, very lucky if your manuscript comes straight accept. Usually they are, they would suggest revisions. If it is accepted, there can be major revisions or there could be minor revisions. If there are major revisions, again, when you do the revision process, it goes back to the reviewers who will check if it has been sufficiently revised and if the revised manuscript is of the standards, and then makes the recommendation to the AE, and then the AE again makes a decision whether to reject or revise. If it is minor revision, usually it does not go back to the reviewers because it's minor. The editorial team will check if the revisions have been made appropriately, and then the manuscript is accepted. So once the manuscript is accepted, then you cannot make any more changes. It is sent off to the for proofreading and technical checks, and that is finally published. So this is a cycle as it generally happens in most journals, almost every decent journal. Okay, so I think at the moment, for some of us or many of you who have published, one thing is that when you open your inbox, you find a lot of emails coming through to publish in journal X, journal Y, journal Z. So which journals to publish your research in? So when making a decision, which there are so many journals now, there are also journals called pseudo journals, whereby, if somebody wants to publish something, they can publish something. But is it worth publishing inside journals? And is, for people who are working in institutions, does it add any values? Or sometimes it could be a negative effect in publishing in bad pseudo journals. So firstly, check the scope of the journal. Does your research or does your article fit into the scope of the journal? It can be excellent research, very well written, very well executed, but if it doesn't fit the scope of the journal, then you're not going to get further. So that's something to check right at the beginning itself. Once you've done that, make sure your work fits with the scope of the journal. The way you write it up, everything fits with the scope of the journal. Check the reputation of the journal. As Mohan said in the previous talk, you would want, if you think your piece of research is excellent and you strongly believe in it, then try and go, there is no harm in going for the highest journal with the highest impact factor, with the highest readership and the highest outreach. So check the reputation of the journal and go for the best journal in that field, in our field. There is something I want to point out to you can look up. There is something called Think, Check, Submit, and it is a campaign to help authors to assess the credentials of the journal, because I said there are a lot of pseudo journals, pseudo publishers, to for somebody who's starting off new, to prevent you from falling into such journals. This is a campaign to help authors to choose the right journals and the best journals to publish their work, to present their work. So, why am I? Sorry, my screen is frozen. Yeah. Okay. So once you've chosen your journal, then how do you, what do you need to bear in mind when you're writing your manuscript? This is an important resource which I would encourage you all to look up. You can find it, it's available free. And this is the International Committee of Medical Journal Editors recommendations for the conduct, reporting, editing, and publication of scholarly work in medical journals. And generally, authors are advised to adhere to the ICMJE advice on publication practice and ethics. Ethics is very important. There is a lot of focus on that. Mohan has alluded to that in the previous lecture. And also individual journals, instructions to authors. So most journals, majority of journals have signed up to the ICMJE publication practice and ethics, but also journals have their individual instructions to authors on how to structure the abstract, how to present the results, how to give the references, etc., etc. Yeah, can you hear me? So, okay, so that's what I would suggest looking up initially. Check the scope of the journal, look up the instructions of the particular journal, and also have a read of the ICMJE, in general, for now and for future. So what happens when your paper is submitted? I went through the cycle initially. So again, let me go step by step until the time it reaches the reviewer. So managing editor checks if the manuscript conforms to submission criteria specific for that journal. So suppose you have a paper that is submitted to journal X, it gets rejected. Don't just submit it to journal Y, just take a step back and go through their instructions on the submission criteria. So once the managing editor has cleared this, it is then forwarded to the editor-in-chief editor, who assigns it to an associate editor if the editor-in-chief thinks the manuscript is deemed suitable here on the scientific aspects of the manuscript. And then once the AE has it, the AE decides, again goes through the manuscript, that's where I come in, and decides if it is suitable for peer review, and then invites 2 to 3 expert reviewers. So what are the questions you ask initially when you're looking at manuscript? This is something that I picked up at a workshop back in 2014 when I first started as associate editor for Human Reproduction. It was Professor Johannes Evers, who was the editor-in-chief now at that point, and he said when a manuscript comes to him, the 3 questions he would ask is 3 bold questions. Is it new? Is it novel? Yeah. Is it true? If it is new, then is it true? Is it really true? Probably we can have a discussion later. You wouldn't be surprised, or we wouldn't be surprised. We're quite used to that. There are publications where the data is not valid, or there is an element of making up, or if you put it in very strong terms, fabrication. So is it true? It is very easy to pick up such things. It's not difficult. And finally, if it is new, if it is true, do you care? Do you care? Does it really matter? Does that piece of work really matter to us as a fraternity, as a reproductive fraternity? The authors, can I ask everybody else to mute themselves, please? So these are the 3 questions that are asked very initially by most of the editors and associate editors And then if the answers are yes to them broadly, then it's passed on to the next stage. So when it is passed on to the peer reviewers, what are the types of peer review? You can have an open peer review. Open peer review is whereby the peer reviewer knows the names of the authors, and also when the peer reviewer makes the review and the comments, the name of the peer review is disclosed to the authors, and also when it is published, the names of the peer reviewers is mentioned or is highlighted along with the original paper that is submitted or published. Single blind peer review, and this is what usually happens, whereby I get a manuscript, I know the authors of the manuscript, I do the review and pass on the review, but the authors do not know who the reviewer is, who the associate editor is. And a double blind peer review is when the reviewer or the associate editor gets the manuscript, the reviewer, the associate editor does not know who the authors are, and similarly, when you give the decision, the peer review gives the comments and the suggestions and the decisions, then the authors will not know who it is. And triple blind peer review is whereby the authors, the reviewers, and the associate editor, nobody knows who the other person is. And I said the most common is single blind peer review, and this is most commonly followed in reproductive medicine journals, fertility, sterility, human reproduction update, the major reproductive medicine journals. Double blind peer review is something we follow for ESHRE abstracts, whereby when I get the abstracts, I don't know who the authors are, and vice versa. The authors don't know who the person judging the abstracts is when they, when the decision goes back. So choosing reviewers. This is a very important step because reviewers are invaluable. I will go through the enormous amount of work reviewers do for journals and in bringing out good research, good science, which is of benefit to us as clinicians and and also the scientific community, whether it is embryologists, reproductive biologists, and also finally to our patients. So reviews are chosen based on their expertise in the specific area of research. As I said, as we all know, reproductive medicine itself is very broad. So I can't just choose somebody who has an interest in PCOS, say, if I have a paper relating to poor ovarian response. So the way I do it, I choose it based on their expertise in this very specific area. And it's always good to have good reviewers. So as an associate editor, my life becomes easy if I choose good reviewers. If I don't have good reviewers, then my life becomes much more difficult. Good reviewers come up with good suggestions, good comments, and good decisions. So these expert reviewers should have the ability. So if somebody is a good clinician, does not have to be a good researcher and therefore a good peer reviewer, and vice versa. So this person who is selected as a reviewer should have the ability to evaluate the manuscript fully and fairly and within an allotted time. Because, we all, when we publish, we do a lot of work and we don't want to be sending a paper out to a journal whereby it sits there forever and forever and forever. We want decisions to be made within a stipulated period of time. The author should be independent, the reviewers should be independent from the authors and declare no conflict of interest. That's very important. It has to be very fairly judged and no biases, no conflict of interest. So what are the three questions I generally tend to ask whilst reviewing? You saw the three questions earlier. Those were, what Professor Hans Evers said he usually asks himself. So himself before passing it on to the next stage of the editor. So let me go through with you what are the questions which I ask myself before passing it on to the next stage to the reviewer. So as an associate editor, what questions do I ask? So what contribution does the article make to existing knowledge? Is it something that is already known to every one of us, or is it something new? Might not be novel, but fairly new, or even if it is not new, if you know the topic, does it add or make a difference to what is already known? Does the article read well? See, we do this most of the times. You must have heard throughout the session, reviewers, associate editors do this altruistically. They don't, they don't gain anything, from financially or for their time by doing reviews. So, does it read? We do it. We have busy lives. We have busy work. We have busy social lives or domestic lives. We have clinical lives, clinical work. We have research work. So, make it easy for the reviewer to read. I don't want to be searching through the paper to find out what it means or where something is mentioned. So the article should read well and make sense. Make sense in the sense that it should not just make sense to you. Sometimes when English is not the first language, or even when English is the first language, there could be a problem. Sometimes what somebody is thinking is not necessarily what is being communicated in writing, and it is very difficult. It's not easy to read somebody else's mind. So although it is the highest caliber research, one should make sure that it makes sense and it is easily communicated to the reviewer. If the reviewer is struggling reading through the paper once or twice to follow what it is, then no way will the reader be expected to follow. Readers are also busy. They're also busy clinicians. And that's why it has to be in a way that is read and presented well, and somebody can pick it up easily. And does the article have a clear message? So you can have the cutting edge research, top of the game, but if it does not have a clear message conveyed at the end, then again, it will have very little impact. So the other one, when the article is passed on to the associate editor, then to the reviewers, and when the reviewers are making the recommendations after the review they've made, they will look at, one of the things they look at is the originality and relevance of the manuscript. So, and the questions that, which I usually ask, and yes should be the answer to all of these is, does the work add to what is already published, what we said before? So as an associate editor, I ask the question, the reviewer also will ask the same questions to establish if the the manuscript submitted is an original piece of work. Does the work add to what is already published? If so, what does it add? And with regards to the relevance, does the work matter to clinicians, researchers, policymakers, educators, or patients? Does it matter to all of these people? Does it matter to any one of them? And how much does it matter? Because that is, at the end of the day, that is why we're doing research, and that's why we want to publish. And finally, will it help readers make better decisions? And if so, how? So most of the readers, so I'm coming from a clinical context. So, you might be of a scientific background, but whatever it is, does it matter to your peers? Does it make any difference to how your peers make decisions? And if so, how does it, how does it make a difference? So when going through the various aspects of the paper, we look at each of it specifically, and starting off with the research question. So we have established, I've looked at the paper, established that it can be classified as original, and it could be classified as relevant. So the next question is looking at the research question. Is the research question clearly defined? There are certain ways to make sure that your research question is clearly defined. I am sure most of you would have heard of for randomized controlled trials or for studies of intervention. You would have heard of PICO, whereby you have to define your population, intervention, comparison, and outcomes. So is your research question clearly defined? And by using PICO, if it is an intervention study. Is it appropriately answered? So is it defined, and is the research question appropriately answered? The question that matters more than, it is the question that matters more than the answer. As Mohan said previously, you can't come up with an idea just like that. It needs deep thought on what the idea is, and then the idea to be refined into a proper question and then defined by the PICO or if it is an observational study looking at a exposure instead of intervention, and then look at the methods to answer your question. So it is so the starting point is defining the question, and the question really matters. It matters more than the answer. The answer really does not matter. So many people have this understanding that if the answer is positive, then it has a higher ability to get accepted into a journal. But that's not what it is. The answer is important, whatever it is. Even if it is negative, it is important. It does not matter what the answer is. It is important that the research question is framed properly and answered properly. It does not matter what the answer is. Even the negative answer could be of huge benefit to the readers, the clinicians, the patients, the policymakers, the economists. So validity of the research. So when you're looking at the paper, of course, the paper or the manuscript submitted is a reflection of the research. So is the design right for answering the research question? So you set out your research question. You have defined it quite well. Is the design set right for answering your research question? Was the sampling right? Was the data collected adequately? Are the methods described adequately? Are the analyses right? So all these have to be an answer, yes answer for all of these. So to be judged as being valid research. There are ethical issues too, as Mohan mentioned previously. Are there any ethical concerns? It is not difficult to pick up ethical concerns, when we read through a paper. Sometimes they're addressed, sometimes they're not addressed. Have they been addressed? Have they been adequately addressed? Many times in papers, we see that the ethical issues are skipped. There is no mention of whether the ethical issues have been thought of. Even if there is no need for ethical approval for a certain study, perhaps a statement saying that the study did not need ethical approval for X, Y, and Z reasons would be useful for the reviewer and for the editor, rather than us highlighting the question back to the authors. So if there was ethical issues have been addressed, have they been adequately addressed? And also, if we think to ourselves, the reviewer thinks, is there any suspicion of research misconduct? Nowadays there is, there are lots of papers out there, and there are papers which come, you would not believe, whereby you will see that everything is addressed. Every ethical aspect issue is addressed because they know that it needs to be addressed. But it is not difficult to pick up at that stage, or if it's, if sometimes the reviewer misses the reviewers misses it at a later stage, that there has been some, there is suspicion of something not being right. And, you have seen, or you would have heard of papers, even after being withdrawn years later for research misconduct. And that is something which should never, ever happen. And it is a real blotch or a black mark for researchers. Results. So how do you present the results? So is the main outcome clear? As I said in the beginning, when you define your research questions, if it is for an intervention study, you follow the PICO, the Population Intervention Comparison and Outcome, PICO. So in presenting your results, in your outcomes, whatever you have set up as your primary outcome or the main outcome, is the main outcome measure clear? So that is, it should be a yes to that. Does the study is the study fully reported? So when you set out to do a study, a very important aspect is to have a study protocol whereby you set up your aim, define the questions, set up your aims, objectives, methods, analysis, and then you don't have the results, but then you're reporting. So is the study fully reported in line with the appropriate report statement checklist? And I will show you in the next slide what these reporting statement checklists are for various types of studies. Are the results well presented? Yes, you can have the best results, but it's also important that they're presented well. As I said, your associate editor, the reviewers, and also the readers at the end of the day are busy people. You want the results to be striking and something that they could pick up and something that would make an impact to all of these people. So is there a balance between the text, tables, and figures in the right manner? Usually, the text tells the story, the tables provide the data, and the figures illustrate the story. So that is what is usually the general way of presenting your research. And as I said, these are some of the checklists. I would encourage you or advise you to look at the Equator Network, whereby they give you a list of reporting guidelines for the various types of studies: randomized controlled trials, observational studies, systematic reviews, study protocols, diagnostic, prognostic studies, case reports. So every type of study, even basic science studies, they will, they give you a guideline on how to report outcomes. So this is quite important. And most journals would want you to adhere to this, these reporting standards. Presenting data in figures and tables. So, figures and tables should be standalone. So when, for example, if you publish a paper and say, I want to present, I'm doing a lecture somewhere, and I want to present data from your paper. The best way is to take off figures or tables and then talk through them. So they must be standalone. Figures and tables must be standalone in the sense they should convey the message by themselves without being able to refer to the text. As I gave an example, if I want to pick up a table, and present it, then I should be able to do that. Usually, for most of my papers, and Mohan and I have collaborated, that's what we do. Figure 1 usually represents data selection for interventional studies, or even observational studies. Figure 1 is usually data selection, how you collect, the data which you are finally analyzing, how did you get to the data? Table 1 gives, and this I'm alluding to as in clinical studies. Table 1 refers to the baseline characteristics of the study population. So the age, the ethnicity, say in my context, the BMI, all those aspects. So baseline characteristics, relevant baseline characteristics of the study population. And table 2 presents the answer for the main research question. So the main research question is answered in table 2, and there are additional figures and tables based on the type of articles. For example, if you have a meta-analysis, all the additional figures would be the forest plots. And if you have more than, a sub-analysis or a sensitivity analysis, more than the primary in addition to answering the primary research question, you could have additional tables, which could either go as presented in the main text, as a table to go in the main text, or as supplementary tables. Okay, so you had your research questions, you had thought about your methods, you have looked at the way you're going to present your results. So how do you go about the interpretation and conclusion of your results? So are the conclusions focused on the data? So these are the questions we ask. And again, it should be a yes to all of them. Are they sufficiently derived from the data? So all the conclusions you made should be derived from what you are presenting in the paper, not from somewhere else, not from assumptions, but from the data you have presented. Are the conclusions supported by the data? So are they focused, derived, supported by the data? And have they been discussed in light of the previous evidence? So if you have a result, if you have a conclusion, you make a conclusion from the result, how do they compare to previous evidence? Do they concur with previous evidence, and do they not concur with previous evidence? If they concur, then justify that. If they don't concur, it's okay, but still you justify that. If your research question, your methods, your analysis is correct, and if it does not concur with what is published previously, it's still fine. If you know that you have done it right, then it's still fine. And if you should still be able to justify it. And at the end of it, is the message clear? And the other thing which I want to highlight is, are the authors going beyond the results in their conclusions? Your conclusions should be just what your data has shown, or what you derived from your data. Don't go beyond what your study has shown. and that is very common. Authors go beyond the results in making conclusions. It's very common. And we don't want you to be doing that. Don't make interpretations. For example, if you have a study of exposure and you're looking at causal or association, don't jump into the next step of, talking about intervention as a result of the causation, which could help. So don't make conclusions any inch or any bit more than the results. Then coming to the discussion section. The discussion states the relevance of the results. Okay, you briefly summarize and mention the relevance of the results. What this evidence adds. So, this needs to be mentioned there. The strengths of the study, as you perceive, and the reviewer and the AE should be in agreement with that. And limitations. Not all studies are perfect, and the majority of studies are not perfect. So please discuss the limitations. If there are limitations, don't see it as a negative. Of course, if everything is a limitation, then that's a different thing. But if there are limitations, don't see it as a negative. Discuss the limitations. That helps that the reviewer, the associate editor, to know that you have the insight, you have looked into these, and there are some of them can be addressed, some of them could not be addressed. For example, when you're looking at observational data, there are so many things you want, but they're not there because this is already existing data set. You could discuss that in limitations. In a randomized controlled trial, the population you're looking at might not be representative of another population. So you could discuss that as well in your limitations. So some examples. And finally, the clinical implications. In a clinical study, as I said, if you do the best research, and if I were to pick up the paper as an editor, as a reviewer, or as a reader, and I think, this is great cutting edge science, cutting edge research. But then if it doesn't really, make any difference to my practice, or if, either substantiate what I'm doing or make any changes, then it's not relevant. And then, if at the end of the paper, if you can make any further suggestions, that's also very useful. And also, we've talked at the various aspects of the paper. The other thing which we would look at, which is the beginning, is the abstract. So when you're writing the abstract, make sure that the abstract, the summary, the key message, or whatever, sometimes I say the wider implication, what this paper adds, this section in the abstract, make sure that they reflect accurately what the paper says. Again, don't make any assumptions, don't make over projections, don't say beyond what your paper has shown or your results have indicated. So it should be accurate. And again, the final bit is the references. Again, when we look at the references, this is also important because, little things, if every bit of it is done properly, then it makes life easy. It makes actually a pleasure as a reviewer or an editor to read a paper, and also the readers out there. So if one takes, pains that everything is done properly, it is really a joy to read papers. So with references, when it comes to the last stage, make sure that they're relevant, make sure that they're up to date. You don't want outdated references. Any glaring omissions. So we look to see if there are any glaring omissions, and also if they're accurate for statement. I was recently reviewing a big, a grant recently, and then some of the references were not reflecting the statements, and that's because some of the references were my papers, and I knew that, what the reference was put to a particular statement is not what my paper said. So make sure that they're accurate for statements. The reviewer could be the person whose reference you're mentioning. So putting all this together, the peer reviewer. How important is the peer reviewer? The peer review is invaluable. Without peer review, research would be unreliable. They are a huge and a very important resource. Remember, doing a peer review involves a lot of time and effort. And as I said, most of the peer reviewers do it altruistically. So there is, they do it altruistically because they have a passion for that field, they have passion for science, they have passion for research, they have passion for something good being done and for our patients. Most of the times they're constructive. If it is a good piece of research, they're constructors. Sometimes there might be problems with language presentation, but really it does not matter. If every aspect of it in terms of the research question, the methods, the results are accurate, does not matter about the language. They're constructor most of the times. If it is a good piece of research, they will give you suggestions and comments on how to present it better, and that's where the revision comes in. And reviewers are a doorway to filter out bad signs. So I've talked to quite a bit, and the question most of us ask, and I did ask myself, and we keep asking this from time to time: am I good enough to publish? Let me tell you, if one does good research, because when you're coming to publish and when you're coming to submit your manuscript, it is a reflection of your research. If you have done good research, then it is not rocket science to publish. Certainly nobody is born with the skill to publish, but it is a skill that you pick up. The first experience might be daunting, but once you pick up the skill, it becomes easy. You will know how to think the right way. You will know how to get a good question. You will know how to put the good question. You will know how to address the good question, and you will know how to present the answers you have derived for that good question. So don't be put off in publishing. It can be done, and it can be done very well if you follow certain principles and ethics. And most of this is available for authors to see on how to adhere to good publishing principles and ethics. And thank you for your attention.
Thank you.
Thank you, Doctor. I think it was a very elaborate talk, and it will help many young clinical researchers in getting their articles published in good journals. The questions will be taken up by Dr. Monica and Dr. Shalini.
Yes, good afternoon.
Good afternoon.
Good afternoon. And so we heard two wonderful talks by experts in the field of research, and we've seen the scientific path of a clinical idea getting into print and for all the scientists to study and see. So it's a long path and a difficult path starting from a clinical idea. Now, we have questions. I think the delegates don't want to lose this moment of asking questions from the experts. The question for Dr. Kamath is, first question, sir, that is how difficult is it to get clinically valid ideas for research? Do you think it is difficult?
Yeah, I think that's the main question here. And we need to understand that that comes with, first is we need to be well informed and well read before we launch a study. So most of us are like, I didn't think training has been looked at much of literature search and, finding out what is already published. So like when I see that, we end up doing studies which have had already been answered, that is something that we call clinical equipoise. So we need to be first of all well-read when we start a study. And then we have to be very keen observers when we are doing practice. So you will know that where the literature stands, and then we practice, we figure out, okay, the literature doesn't have an answer for this particular clinical scenario. So there'll be a lot of clinical scenarios. So it's a learning experience. You kind of slowly figure out what are the good questions. The other issue is what we think is a good clinical question, the person across the continent might not think like that. What we feel is very relevant to our population might not every time be the same what the editor feels. Certain certain practices that are there in our country might not be, looking very high priority, as we call it, on the editor's table. So those are the issues. So probably that's where the problem is. I think the most of the time we need to spend is to actually get a good clinical question. And that's the main thing I would say.
Yeah, if I can come into that, I completely agree with Mohan. How you get your questions, is I think most of the audience here are practicing clinicians or embryologists. It's from your daily practice. If suppose in your daily practice, you come up with a question and you don't know the answer, what you can do is, we all have computers now, in front of us. We do a quick search and see if you have the answer for that. If you can't find an answer in the literature for that, then that becomes a question. But again, as Mohan very rightly said, is the question just relevant to your population? Is it very finite to your population, i.e. in the region you're working? Is it expanded more towards the larger population, say your region in India, or is it Asia? But the best thing would be, if you want your paper to be accepted in global journal, is to have the question being relevant not just to you or a specific a region, but to the wider audience. For example, I get a paper saying in the title itself, it says, a paper within the, whatever the title is, within an Indian population, say, or a Chinese population, say, or, another population, say. Why would I, sitting as a reviewer for a global journal or an editor for a global journal, be interested in something which reaches only a specific finite population? So that's very important as well. Would you agree, Mohan?
Yes.
Thank you. Secondly, when we have young researchers who are not working in institutes, but you are having a private practice or institute. So then when the question of ethical clearance comes up, where does that ethical clearance, how do they take it?
No, so that
I'll ask Mohan to handle that, because I don't know the situation in India.
That we have like the IFS, there's an independent ethical committee. So there are a lot of, like FOXY has, I believe. So there will be independent committees which you'll have to, probably organization you'll have to approach. I am aware, I think IFS has that. And it has to be registered with the central authority, regular authority. Then only it is legal, the regulatory norms. You can't have a committee which is not registered with the DCGI. So that is something that we need to understand. But I would like to stress here again, launching interventional studies without clinical trial registry numbers is totally a no-no now. Even in India, it is prospectively registered trials that have to be going. Otherwise, we can't even register them.
Okay, thank you.
So if I can come on that, see, when I'm reviewing for a journal, it's fine. You have the entire manuscript, so you can read into it a bit more. So when you review abstracts for ESHRE or ASRM, say, for example, I'm reviewing abstracts for ESHRE, the word limit is very minimal. So people say that ethical approval has been obtained. We know that that is not sufficient. So, but we can't question more than that. So sometimes, they do get accepted for as oral presentations or posters for these conferences. But you will see that most of them will not make to the full manuscript, because, I'm not saying anybody, I'm not pointing a finger at anybody, because we know that most of them have not gone through proper ethical approval. It says ethical approval. Say if you're in a single-centered or a single-centered practice or a private practice, it doesn't mean ethical approval means 3 people sitting across the table and saying, yes, it can be done. It has to go through the proper kosher way. And that's what we face, when we are reviewing abstracts for ESHRE. It says ethical approval. We know that, it's probably not the right ethical approval, but unfortunately, we can't ask any further questions. But the way I know is many of those that are presented do not make it into proper good journals, and I know then it is not the right, it's not done properly. Okay. Would you agree on that, Mohan?
Yeah, agree.
That's one problem we can face, and it is not difficult to make out.
Okay, ma'am. How do the reviewers check the validity of a submitted study? What do they look for?
They look, somebody who's asked this question has not listened to me then. No, I can't repeat.
That was a question by me. Like, what are the checkpoints? Do you have anything like, because there are now new checklists for that, the randomized trials and all. Yeah.
Oh, yeah. So see, the checkpoints is, if you look at the Equita website, which I forwarded, then it gives a checklist for the various types of studies, intervention studies, observational studies. So all those, that would be actually looked before it comes to the reviewer, the associate editor, by the editorial team. They would look that all these have been adhered to. For example, if you're submitting a systematic review, say, whether you have adhered to a certain PRISMA guidelines or a PRISMA checklist.
Yeah, can I add to that? Yeah. Can I add? Yeah.
Please add.
Yeah, so see, nowadays there's a lot of, issues in terms of validity of trials. So like now there is, we go back and check the baseline variables as well. So if we have, issues with the baseline variables, we can figure that out. The age, the BMI, and number of oocytes retrieved, and there will be so many clues there. So sometimes, and the way how fast they have recruited patients, then also we actually get a lot of information from trial registry, the protocol trial registry. So if there is no trial registry, then we are not happy about it, because as peer reviewers, as Shesh would have has elaborated, we are actually blind to what is happening. We just go by what has been submitted, and it's a challenge to figure out if everything has been done in the way it's written. So a trial registered one is gives you a lot more confidence. Okay, they have followed the norms. It is prospectively registered, and they have not changed things midway according to how the study kind of panned out. So there are a lot of things now the reviewers actually look at, and especially validity is one of the major concerns, as Shesh would agree, that is coming out.
Yeah, if I can add to that, when reviewers or when you become an editor, you come to the stage where you have reviewed quite a few papers, you have done research yourself. So even if I have a paper that has ticked if I have a paper that has ticked all boxes saying that everything is, with regards to this, then that also brings a suspicion, because no paper no research can be 100% ticking all the things. And it's not easy, because say if you go up and look and say these are the ones to be followed. I have seen papers, I have come across papers that have been fabricated, and it is not difficult to see through them. Perhaps, people who come through me are being lucky in the sense that it stopped there, it is rejected there. But then if these such papers go through where there is a lapse in reviewers picking up and go through, you're still in danger, because it might come back to haunt you 5 years later, 10 years later, when the paper is withdrawn. And if you have a paper that is withdrawn, then I think your reputation is in dire, has dire problems.
Just one last point. What already happens, I think Shesh would agree on that, is many times the reviewers reject the trial and give a lot of points for why it is rejected. And many times the same papers then eventually get published in another journal with those whatever the points were raised, they kind of change it or do it in a way that's not correct, and then eventually they kind of work it around, and you find the same study which we had rejected for reasons that we are not happy about the validity, getting published eventually in another journal. It might be not as high as let's say fertility study, but it might come down, but eventually it will come to the clinician and the readers, and that's the worry.
Yeah, but then big journals keep an eye of these papers which probably would have been rejected, and to see if they're published elsewhere. So if somebody is unfortunately there is research fraud as well, and if there is research fraud, it might come back to haunt you at some point. So for the most important thing is at the starting point, get your question right, design it right, don't make up anything, no shortcuts, people out there are not stupid.
I'll just like to ask that because this famous paper which we had in Lancet, which was retracted in COVID and HCQ, after that they have changed their process of validity checking and they have made it more stringent. So it has the other peer reviewer groups like the policy makers, have they also changed the way they're going to validate in future, or it was just limited to Lancet?
I think the Lancet one was, I think COVID made a lot of, because COVID is, the whole world was reeling under COVID and it was an emergency situation. So there were a lot of publications that went to fast track peer review, or they were even released before peer review publication. And that was a major issue with COVID, and even in big journals, as you saw in Lancet and what we've been living through. But journals have always had a very kosher process to the maximum extent they would. And this will only highlight how, if things are not done properly and, authors have a paper published, how it can come back to haunt you, whereby it is retracted when you have a worse reputation hanging over you if that happens. So don't ever publish such, any work which is not valid. Journals will pick it up. As I said, if it's not picked up in the initial stage, it's picked up later on. Even if it's published, it can be picked up 10 years later. And, you don't want to put yourself in that. And we've seen with COVID was, there were lots of fast track, publications even before peer review or fast track peer review, things like that. And there's been a lot of misinformation from there. Unfortunately, added to that, political interference from the soon to, political interference, politicians making statements on the efficacy and non-efficacy, non-scientific people. Everybody had their own opinions and views. So that brought a lot of confusion with COVID. Hopefully it will not happen next time.
Thank you. I'll request Dr. Shalini to take over the rest of the questions in the chat box. Dr. Shalini is there. She's joined.
Otherwise, we're finishing it. Yeah.
Dr. I don't see her name in the participant list.
I think you can.
It's okay. Then just two quick questions so that we finish on time.
Yeah.
One is a question asked that a person who a study they want to publish it in parts in different journal, one part in one journal, the other. So then the material and methods become similar. So will that amount to plagiarism, like the same material, methods, and the study is subjected to different journals in different journals?
Mohan, shall I take it and then you can come on?
Yeah.
So it depends on what you want to publish. See, if you're publishing, say you have a study, if you're publishing clinical outcomes in one paper and then you're publishing the probably the basic science aspects in another paper, then that's fine. But if you have the same paper and if you're saying you're presenting half outcomes in one paper and half outcomes in another paper of the same thing, then that's a different thing and that cannot be done. But if there can be a research questions and you can look at different aspects. You could probably say, look at the basic science aspects. You could look at the clinical aspects. Then they will go into two different journals.
Yeah, I would agree broadly with Shesh. And main thing is you can always reduce, and if there is a valid question, two questions coming out of the same study, then you can just quote that this study has been published and this is just the extension of that study, whatever outcome you want to, like neonatal outcome or something. And in the method section, you can put this reference of the earlier study and link it up, saying that it has been in detail described in this particular study. But that is something that can be done. And plagiarism, there is a limit like 20% or 15%. So many times the methods will be quite
audio is.
I can hear. I think he's got frozen. Can you hear me?
We can hear you, ma'am.
Yeah,
Okay.
I think he's back.
Okay. Then it's whose responsibility to run a plagiarism check, the editors or the reviewers?
No, the editors and reviewers usually don't run the plagiarism check. It will be the editorial team, so the managing editor. So they will run the plagiarism check. So by the time it comes to us, it will be run probably, or after it has been accepted, it is run again. So we don't do that.
Okay, I think so. That is the end of the questions. We had an excellent session from our experts, who are experts not only in research, but academics, clinics, and totally globally privileged persons. So thank you so much, Dr. Kamath and Dr. Sunkara. It was a pleasure listening to you and learning from you. It was a great experience. Thanks a lot.
Thank you very much.
Thank you.
Have a good day. Bye-bye.
Thank you, speakers, Dr. Mohan Kamath and Dr. Sunkara. And I would also like to thank our chairpersons, Dr. Vanita Jain, Dr. Deepa Goyal, Dr. Monika Verma, and Dr. Shalini Yadav for making the session so interactive. Now, I would like to invite Dr. Ruma to propose the vote of thanks.
Thank you, Dr. Divya. I mean, this should be a quick two-word thing, which is just saying a thank you. But since we kind of completely messed up our beginning, I think I'm going to take just 2 minutes, bear with me, and do the routine on thanking everyone here. So the idea of the workshop had already been explained by Dr. Kamath in the beginning, and we do know that the pandemic has changed our working in known and unknown ways. And one way that it has affected perhaps the way that our students who are short-term, like 6 months in which they would do their study, is that also in the face of dwindling numbers, is that they are focusing more and more on retrospective data. And this workshop was an attempt to kind of address that, to address their concerns, to help them do it a little more in a better way. And the first session speakers, I'd like to thank them immensely for having elaborated and illustrated the tenets of a retrospective study and the biostatistics involved in the same. I would also like to thank our experts for the subsequent 2 sessions, Dr. Abha, Dr. Neena, Dr. Radhika, Dr. AB, and Dr. Harpreet, who helped in, who listened to the study proposals, helped in critiquing it, and hopefully making it better with their suggestions. And I'm hoping that the study presenters will take their suggestions. I would like to thank, of course, the last session speakers, and impressive body of work, both of them, and we certainly will benefit from their talks. I, along with my convener, Dr. Kamath, our mentor, Dr. Basu, co-convener, Dr. Swati Verma, and our coordinators, Dr. Puneet Arora, Dr. Harpreet Sidhu, Dr. Monica Verma, would like to thank the chairpersons, Dr. Pushpa, Dr. Sanjeev, Dr. Puneet, Dr. Benita, Dr. Deepa, and Dr. Shalini for having made this an absolute success. Also, Dr. Divya, a little word of thanks to you, and to Dr. Aradhna for having done this so brilliantly and flawlessly. Thank you.
Thank you.
Hopefully, the attendees could join us again in our next workshop. Dr. Kamath, would you like to add anything?
Yeah, probably we would have more targeted sessions where we will go step by step and guide students in their work, because it's a long journey. It's never easy to kind of put into a box of a half-day workshop or something. It's a constant thing, and we have to go step by step. I understand that as clinicians, it's not easy to grasp everything. It takes time, and with examples, we want to do it. So we will, hopefully we'll do it better without the COVID around, and let's see how we progress. But please, watch out for all our programs that are going to be rolled out in the next 6 months. Yeah, thank you.
Thank you. And the brilliant team of organizers, Dr. Jindal, and her absolutely brilliant, always available Dr. Manisha. I haven't seen her in this, but do pass on my message to her. She was there all through to help us out with all the organization. Thank you so much.
Thank you, Ruma, and everybody else. Thank you, Shesh, for joining us in the morning.
Thank you, Mohan. When you organize, sorry, I don't want to interrupt. When you organize the next workshop, I think it would be good if, there is a lot of hunger out there. There are a lot of young people who want to publish. Maybe a session starting off, how to ask a question. And I think that's the most important thing. And as we stress, the most important thing is to get that right, how to ask a question. And then, think about maybe you should do a half-a-day workshop. That's what I tell my fellows. Ask the question right, and then you can get the other things much easier.
Yes, agree.
Maybe we should run a workshop on that.
Agree on that, Shesh. Yep, we'll have you there.
Not in the morning.
Yeah, sure. Thank you all. Yeah.
Okay.
Thank you.
Thank you. Bye.
Thank you.
Bye-bye.